cast away. Alienated from the aids of that inventor in disguise. Ideas ahead of time dismissed with narrow eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his point. Benefactor boy, can't you hear his voice? Talking about 0 point, the points lost on them. Kevin structures crumbling from the same old stem. They laugh like I'm crazy, but I see it all so clear. Exploited labor, unheard injustice, burning ears. Fighting for a change in this wasteland of noise. But they call me foolish, wanting and ploys. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his point. Benefactor boy, can't you hear his voice? Chasing revolutions in the darkest nights. A dreamer with vision beneath the laughter and noise. A future so bright waiting for the right choice. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his point. Benefactor boy, can't you hear his voice?
And in the depths of shattered halls, I wandered all alone, casting whispers, blinding chains, demons of my own. Toxic deafening, down spread on my frail soul. I once feared my mirror, haunted by my role. But in the echoes of my cries, just still I emerge, guiding me to where my true results are. Now I rise from the shadows with wings of fire and sand, free from the chains of sorrow, while this path of forever deepen. Shattered glass darkness turned to dawn. I wear truth, that's my guide. Anxiety's dissolved in the sun's coming in ray. You see my destiny through time and space. The fears that once drew to reality. For in my heart a new world is proclaimed. Now I rise from the shadows with wings of fire and sand, free from the chains of sorrow. On this path I'll forever depend. With symmetry I found the power. Blessed stranded by the hour. Together we will come away. Revolution calls and I'm not strong. Now I rise from the shadows with wings of fire and sand, free from the chains of sorrow. On this path I'll forever depend. In the depths of his oppression, it's the rise of a true nation.
What's going on, everybody? I'm your host, the Benefactor, and welcome to today's League of Extraordinary Inventors pregame show. The League of Extraordinary Inventors podcast hosted by Mike Kay from Faraday Research. As you might know if you follow, our podcasts start at 9. So we have about an hour to discuss some of my research, and then we'll get into the League of Extraordinary Inventors at 9 o'clock Eastern Standard Time, so in about an hour. We have a few videos to watch, some data to go over. We do have some data collected from the Lightning Thief. As you all might be aware, we are in the process of manufacturing the Lightning Thief for you guys to purchase. We don't know any more details other than that. I can't say price, I can't say time frame, but I can say that it will be very, very cheap. And actually, let's pull up the data sheet, and we'll go over some of the features of the product list, product lineup that we have listed for 2025 from my new Coil Kits Lab Shop. There we go. All right. So I'm very excited to announce the new Coil Kits product lineup for 2025. Introducing our first product of the year, which is going to be the Lightning Thief. Now, this is all open source. If you wanted to and you had the technical abilities, you can go on my channel, look up Michael's modified ABHA excitation circuit based off of Daniel Nunez's modified Jewel Thief circuit, and you can put this together yourself. It's all open source. This is just trying to provide this system to people who need it and might not have the means or time to build one themselves, but have a coil they want to test with. Now, we haven't tested the Lightning Thief with other coils outside of the ABHA, but I am positive that it will have some kind of interesting results regarding any kind of coil you hook it up with, because, again, this is based off of a Jewel Thief, which you can use any kind of bifilar coil. So, with that said, the features of the Lightning Thief is it's a next-gen circuit designed to squeeze every last drop of energy from your power source. Now, it extends lifespans of your battery by squeezing, expands the lifespans of your devices by pulling energy from the batteries other devices think is dead, when devices won't recognize the battery anymore. It has pretty good efficiency. We haven't tuned it exactly to the efficiency that I'd like, or to the potential that I think is possible with this circuit. With that said, it's still pretty efficient in the fact that it can squeeze extra energy out of a battery and last a little bit longer. It's emergency ready, so it's ideal for off-the-grid lighting and heating during critical moments, such as power outages. And this is going to be critical for me this winter, so this is very good news for my situation. We do have a 32-watt LED panel as well coming in the mail that we're going to test our circuits out with for efficiency. It is a eco-conscious device, so it works wonders with lead-acid batteries, recommended 12 volts or more, for sustainable energy use. You know, it literally is a green device. It's the Lightning Thief. You know, it turns waste into watts. It's essential for off-the-grid living. So, in my opinion, this is going to be a very good device for anybody who wants to have some kind of off-the-grid solution to have backup power. So the Lightning Thief are these two devices right here sitting on top of the cylinder samples. So the green is what I'm going to choose. It's not the final design. These are prototypes. They have small little mini breadboards in there, so it's not a proper PCB, but we do have a couple of sample PCBs coming in the mail, and I'm going to put those together for the team and have the team test out those before we go roll those out for consumers. The next device that I'd like to discuss is the pulse circuit device. So this is going to simulate a AC sine wave. It's not an actual true AC sine wave. It's actually an AC square wave that the circuit that we're working on is going to be able to produce. But in the future, we are aiming to upgrade this next device on the bottom to a true AC sine wave. And I might throw in options for having a mini stereo amp board in there instead, if you would like that true AC sine wave, which, in my opinion, is going to be essential for over Unity production. Although we're not marketing over Unity yet, Lightning Thief does not achieve over Unity, not yet at least. I'm confident that we can at some point. But the problem with the Lightning Thief is, while it's able to extremely efficiently squeeze every last drop out of your battery, as we've seen with the system running for 30 hours, and it ran the 12-volt battery all the way down to 5 volts. So it's able to squeeze it for every last drop. Now, the problem is that it F's up the duty cycle, right? And the oscilloscope is showing like 10 to 5% on and 90 to 95% off. Now this is, it significantly lowers our power factor here, but it's, it's very good for stepping up voltage while maintaining the current, as we've seen with the readings that we get. We get about 470 milliamps coming directly out of the power source, the battery, and then coming directly out of the coil's output, before it gets to the collector. So that's right on the direct positive output of the coil. You get 457 milliamps. So a slight loss, but you're stepping up the voltage like 10 times or 20 times or more. So at that point, it's like, that slight loss is negligible compared to the overall wattage that you gain. Now, the problem with this is once it hits the Joule Thief circuit, though, and starts oscillating, it loses a little bit of current. Actually, it loses a decent amount of current, and it loses half of the waveform, so it significantly lowers the duty cycle. Now, I'm not sure that's exactly what's lowering the duty cycle, but that I have a feeling. We need that true AC oscillation, the true AC sine wave, to produce the over unity effects that we need. But regardless, the pulse circuit is going to be able to achieve what I'm going to demonstrate to you in a few minutes in the video, the Wattman video, where we reduce our input requirements from 24 watts all the way to 14. Now that's a 10-watt reduction. Now with this unit, it's not green, but it's going to be called the green machine, okay? And the green machine is this little box down here. It's going to, my plant is not a working prototype, by the way. This is the second product lineup of 2025, and it's going to be a little bit more down the road. But it's going to have an LCD panel like you see up there on the top, and that LCD panel is going to be able to read the input wattage coming into the box and the output coming out of the stereo or the mini board, whatever you have in there, pulsing your circuit. So this is going to be essential. It's going to be just like essentially having a Wattman plugged into the wall, only you don't need it plugged into the wall. You can have it mobile. And this is going to be our driving circuit for any kind of magnetic rotary. I did have a magnetic rotary, a V-gate, up on top, demonstrating how you can sit one on top of the Rodin coil or the ABHA coil. But I don't think I'm going to be marketing the V-gate. We have to test which magnetic rotary is going to be most efficient and easiest to set up in a kit. And once we determine that, we will be rolling out our own magnetic rotary as well to sell with this pulse circuit. Now, the green machine. It's the ultimate pulse motor circuit, fine-tuned for Rodin coil excellence. Again, you can probably use any kind of air gap coil, as long as this bifilar has two, channels. It's ready to go. Just plug in your coil and a magnetic rotary. It's that simple, guys. That simple. Okay? It's dialed in. Adjustable potentiometer lets you fine-tune the frequency for peak efficiency. Okay, you'll have a dial for frequency, and you'll also have a dial for the gain. Stay in control with the LCD display displaying the RPMs of the magnetic rotary, the voltage current draw, the RPMs and the voltage current draw. So you can monitor input performance at a glance. And I also plan on having an output monitor as well. So you can monitor the current and voltage coming out of the circuit going into the coil. Now, this is a highly efficient design, specifically designed to maximize the Rodin coil's potential for energy generation, testing, and backup power systems, used along with our tuned method for peak efficiency. Now, Michael and I have discovered a method for tuning the magnetic rotary, and you'll see that in our previous videos, but I'll discuss it briefly in a minute when I show you the Wattman video here shortly. The green machine, sustainable green energy by turning rotations into revolutions. Yes, the next industrial revolution is upon us, ladies and gentlemen. Stay on the front line of zero-point energy technology and subscribe to my Patreon for the latest on these upcoming hot products. So I do have a Patreon. That's patreon.com/BeneficenceTV. And if anybody wants me to put that in the chat, I will. But these are our two product lineups for two products lined up for 2025. And again, I do plan on having a magnetic rotary at some point. I can't promise when because we still have to test the efficiency and which one is going to be most convenient and cheapest for us to roll out for a mass production. So that is the new Coil Kits lab shop, ladies and gentlemen. So stay tuned for more information on that. Very, very exciting information coming out of Beneficence TV. All right, so let's put that on hold for a second. Hey, what's up, Mike? How you doing? How you doing, everybody? So I'm going to pull up a couple of videos for us to check out. This is going to be a pretty chill pre-game show. Just a few videos and some data to go over. Nothing big or groundbreaking to announce. Although the results from the Lightning Thief were pretty good, we did get to squeeze that 12-volt battery all the way down to 5.13 volts on the output of the battery directly. I have a charger coming in the mail tomorrow. We're going to charge it back up, and we're going to test the circuit without the coil, see how long it lasts. But I've got a feeling that it might crap out a lot earlier than 5 volts on the output, specifically because this circuit, as we've seen, can multiply voltage like no other. So, yeah, it just has a unique ability to squeeze all that usable energy like a sponge, you know, wringing it out in the sink. Just squeeze it for every last drop. Now, there is a warning about doing this. Specifically, it accelerates the sulfation process. I believe that's what it's called. Salination? I think it's sulfation. But yeah, the sulfation process where you have sulfur crystals being formed in the battery, preventing it from holding a charge as long. But I don't think this is a problem, specifically because if we run into this issue where the battery is slowly losing its capacity, then we can rely then on our Bedini knowledge and build a Bedini SG or some kind of Bedini circuit to rejuvenate that battery. I don't think that's going to be much of an issue. Yes, you can damage it. I did want to see how low it could go, though. Yes, I wanted to see how low it would drain it. Because I wanted to see where we are in terms of how much energy it would take for it to actually stop the fans. So we stop at around 5.13 volts. And I want to see where we're going to stop and what time frame we're going to stop without the coil attached. You can drain LED aluminum batteries down to 0 volts. It will restore in seconds. Effing amazing. Yes. So, I don't think it's going to be much of a problem because we're only doing it once. But if we run into any issues, we will build a Bedini circuit and try to desalinate, desulfonate? I don't know if I'm getting that term right. But we'll try to rejuvenate the battery. Okay? It's not that big of a deal. But it is important to note that Mike is absolutely right. Anything under, 11? I think he said 11 or 11.5 volts on the output of the battery source. You don't want to drain it more than that because it does put a strain and it can reduce your capacity in the battery. Get a $10 charge controller. It would disconnect from the battery to save it. Well, yeah, I could just monitor it for now, but that's a good idea, Mike. Yeah, I could do that, definitely. We would like to have something in the future where I can just set it and forget it. You know, just set it, forget it. When it reaches that voltage level, like you said, it just disconnects to save the battery. That's a good idea because we want to do more of these long-term tests. and see the longevity of the system on a off-grid platform. So that's the primary goal here. Is my goal here is to focus on off-the-grid platforms or off-the-grid applications for this technology. But that's not to say there aren't any practical applications for on-grid. Like, I believe that you have the ability to do extraordinary things on the grid, but I believe the most easy an efficient use of this system would be on a mobile application. In my opinion, it just makes the most sense, and it's the easiest to try to get into the most hands that need it the most. You know, imagine a scooter that just runs itself. You don't have to recharge it. That's the end goal here. We're not there yet. We're not there quite yet. Gerald says he has an idea that he can share with us and how we can do the self-charging scooter. That he has one. He says he has one working, and he can show me how it works. It doesn't even need a coil, so, or at least it doesn't need an alpod coil or a rodent coil. So that's interesting. So that's our end goal, right? We want to, in phase 3, get a scooter that's either extremely efficient, at least a COP of 1 or greater, or if we can push it to that ultimate limit, get it to recharge itself and not have to worry about energy, right? You just set it and forget it, and you don't have to worry about the input at all. So that's the ideal system here, specifically for my situation. I could really use that, save on gas. I know a lot of people could use that as well. And specifically in third world countries, you know, people are really struggling, not just in America, but all over the world. So we want to try to bring this technology out to as many people who really need it as possible, and not just up the price to a ridiculous amount and reserve it for an elitist group, like we've seen with some of these companies that have utilized some of this technology. They'll take it and they'll utilize it for an elitist, rich group of consumers, and it's not on the market for average, everyday consumers. You know, it's a damn shame. But I'm aiming to change that. We're going to try to bring some of this technology to you guys in the near future. So that's our product lineup for 2025. I do have a lot to discuss with Mike. So Mike, if you have time this weekend, please email me, and we have some things that we can discuss going forward. Now, with that said, I'm going to try to bring up the videos here in the momento. All right, everybody, here's something really cool. Oh, okay, hold on. Why is it like that? Let me see if I can flip it in the program. If not, I'll have to bring up the other video. That's weird. It's on its side. No matter. We'll bring it up in my Patreon. These videos, by the way, are all available on my Patreon early for those who like to support my research. You get early access to all of the research. It is all open source, so eventually it gets dumped onto YouTube and Rumble at some point. But if you want first dibs and you want to help support some of the things that we're doing in trying to light the world, then head over to patreon.com/BeneficenceTV. And I do also give freebies out there as well. So you don't even have to subscribe and pay. You can be a free subscriber and get free access to some of the early stuff. And let's head over to Patreon right now so I can load up that video, since it seems to be turned about 90 degrees clockwise. Okay, here we go. All right, so the caption for this video is, I've been waiting a long time to test the efficiency of a magnetic rotary. Now, this is a simulated magnetic rotary, but for our system, right? Today we were able to get some readings with the wattman on our input, and here's the results. Let's bring that up. All right, everybody, here's something really cool. We have the stereo method hooked up right now. So that's a closed circuit method, not the open circuit Nunez method. 10 volts from our power supply at 140 milliamps, okay? We're gonna spin this little neodymium magnet and we're gonna monitor the wattage, okay? Oh, it's not gonna show it. Oh, you gotta show it. There we go. Okay. So, 7.3 because we don't have it on. We're gonna turn it up. Check this out. Okay, let me take that. I'm gonna take the magnet out first. Okay, we're gonna turn it on. I'm turning it up. Look at the watt consumption. 24 watts. Okay. Now watch this. This is so cool. We're going to put the neodymium magnet in there, spin it up, increase the frequency. Wow. And it goes back up, 24. We saved 10 watts of power by spinning this thing. Holy crap. Yes, holy crap indeed, okay? So when the sphere is spinning at high RPM, we saw a reduction of at least 10 watts on the input monitor using the wattman. Turning the stereo amp all the way up, the wattman shows us it requires 24 watts to run the system from the wall to my power supply to the mini board to the coil using the closed circuit method. Now, this is not the Nunez method, which is the open circuit method, which you hook up a load. This has no load hooked up. It's essentially recycling the energy and creating a stronger electromagnetic field, or rather two counter-rotating electromagnetic fields that is able to recycle the energy in a way that creates kind of like a resonance cascade, where the resonance just gets out of hand and it has nowhere to go. So it just recycles in the system and builds and builds and builds. And we can utilize this by synchronizing the neodymium sphere to that spinning electromagnetic field. And once we do this, once we get the sphere to spin at a high enough RPM, the power requirement goes all the way down to 14 watts on the input on the wattman, indicating an approximate efficiency increase of about 41.67%. Incredible. Now, right now, this is only useful for wireless induction because I have not figured out a way to utilize this closed circuit method to actually hook up to a load, right? Right now, the way to utilize the efficiency of this system right now is to hook up a magnetic rotary, get that rotary synchronized and spinning as fast as possible, and that induces wireless electricity into any kind of pickup coil that you have around your primary driver coil, okay? So this is very important because that is a technically free energy, right? You're saving on the input and you're also giving out that free energy. You just have to have the right pickup, and you have to have the rotary at a very, very high RPM. Now, my theory is that if you can spin it at the resonant frequency of the system, if you can get it to ramp up all the way by tuning it, and there's a specific way to tune it, it's very hard to get it to go at high RPMs. But if you're able to do that, if you have a stable enough field in a system that is powerful enough, you, in my theory, if you can get it to go to that resonant frequency range, in terms of spinning and synchronizing, I feel that that's the sweet spot for like we see in the Nunez method, the 10 times or whatever amplification on the output. Like you'll get good gains on the output, very, very small, minor amounts though, and then all of a sudden you'll have this range where it just drives up. So that's my theory. Right now we have to put together a magnetic rotary capable of testing that theory, but that is the next set of tests that I will be doing regarding the green machine. Now, the green machine is going to be an all-in-one system. It's going to be able to do this, all on its own. You just either plug it into a wall or a power source, and it should be able to replicate this setup right here. That's what my goal is. So, and then you can have some kind of magnetic rotary. It doesn't have to be the neodymium sphere. We haven't reached that point yet, though, to decide what kind of rotary we're going to go with. 41.67% reduction on the input is absolutely freaking incredible. I mean, I don't know how else to say it. Like it's insane. That's 10 watts that we objectionably empirically saved, right? You can't argue that the watts on the input went down. They did. Okay, so whether that's usable on a load or not is questionable at this point, but it's in my belief that if we reach that resonant frequency for tuning our sphere, that we can actually get those gains that we're looking for. Regardless, that's free energy from the wireless induction. So if you have a small, LED lamp, you have it going fast enough, that's, you're powering that lamp for virtually like nothing at that point, So this is very, very cool stuff. We're going to test that on the, also on the LED panel, the 32 watt panel, because it is also my theory that we have to get the load in resonance, because the load, it acts as a resistor or capacitor, depending on what kind of load you have, and you want to aim to adjust that to be in resonance with the rest of the system. And what I've seen reading the test that I did specifically on the Lightning Thief with the 12-volt battery is I seen a mismatched impedance from the load to the coil. So what that means is we basically have we don't have it synchronized. We don't have it in sync. We have the load at a different frequency because the load's not matched properly with the rest of the system. And this means that it's not at its peak efficiency. Now, it's my belief that matching the load properly and getting it in resonance with the rest of the system is key here for tuning it properly. And we're going to do that by testing higher demanding loads, specifically that 32 watt LED panel I have coming, which is very exciting. I'm very excited to test that. I think we're going to get some good results with that and the battery and the Nunez method. But that's going to be in the near future, so stay tuned for that. Regardless, the system seems to be doing something remarkable, and I want to get into more hands. I want to get this system specifically into some of our team's hands so they can test it and maybe figure out a way that we can actually apply this to something useful, right? Other than, just powering low lighting or whatever, because that's really all that it's going to be useful at this moment, other than testing from further research and development. Now, that's what I want to do. I want to open source this and push the bar a little further with some of you guys, because I know a lot of you in chat, you come in all the time with your great ideas, and you're way smarter than I am. So, I want to make sure that everybody has the opportunity to play and test out this kind of system, and see if you can push the bar a little bit, All right, so let us go to Alright, so this is an update video that I have on my Patreon that I haven't released yet to the public outside of the Patreon supporters. This is just a couple of updates on the coil, okay? When we were testing the coil with the Lightning Thief last night, if you're not aware, we were able to get that 12-volt battery to light 5 neon lamps. So that's approximately 300 volts, that requirement minimum to light those 5, on top of the 12-volt DC requirement for the 2 fans we have. So, and then we have 2 white Arduino LEDs, nothing much, very small. But then in the back, if you notice, there is this green LED hanging off the bottom coil, which isn't hooked up to anything. It's the top coil we're testing, the Mark 1, that's hooked up to the Lightning Thief. The bottom one, the Christmas coil, is just simply has 1 channel hooked up, input output to an LED. That's it. And it's using wireless induction. Okay, so in this, this, I can plug it in right now at 5 volts. It'll still go all the way to probably 1 volt. This is very, very efficient. Wireless induction is probably the most efficient, the most efficiency that I've seen out of the system regarding how easy it is to do. Once it's in resonance, it just does it. Right, you have a pickup nearby, and it'll induce the energy pretty easily. And if you have a rodent coil or vortex coil of some sort, it will pick it up a great distance from the coil, not just sitting on top of it. So I could actually lift the Mark 1 coil up a little bit, probably about a half a foot or more, and it will still light this LED, kind of like a Tesla coil, but without the dangerous discharge. So pretty cool. Okay, everybody, so here is the 7.5-hour update. The neons look really dim. They don't look like they're getting a lot of power. But if we look at the... So I did actually discover that it's burning out the neons. So I went through like 10 of them. The multimeter here, it's not hooked up, but if we look at it, it'll read 52 volts. And 12.4 volts, down from 12.61 when we started. And if we take a look at the current now... So this is actually another issue that I had with measuring the current. This is a new multimeter. I thought it was going to auto. I thought it had an auto mode where it would just switch to from AC to DC current, but it doesn't. So I was getting the wrong reading for the current. The new reading, I will tell you in a moment. But just know that it's not that it's inaccurate in the sense that we aren't seeing something weird with the current. We definitely are. And actually, I'll just tell you now. What's coming out is 470 milliamps, right, from the battery, which makes more sense, right? I was like, there's no way there's 18 milliamps coming out of the battery and it's powering everything. No way. So 470 milliamps seem to be coming out of the battery. And on the output coil, output wire of the coil, before it hits any of the circuits or the load, just on the output positive of the coil, it's getting 457 milliamps. So that's very, very slight reduction. Now, keep in mind, this is on top of the voltage multiplication of, like, at this point, it's like 20, 21 times the voltage, because it's able to power all those neon lamps and the load. So, that's pretty interesting. Now, it's not translating because of the duty cycle, but it's not to say it's not there, okay? It hasn't really changed. At 16 milliamps, 15 to 16 milliamps. Again, that's not 16 milliamps. That's probably closer to 470 milliamps. And then we're getting 457 coming out of the coil, which is extraordinary. Amps input. About 9 to 10 milliamps output. And directly from the coil's output, we actually have the full 15. This is the interesting thing, though. While it's not an accurate reading of the milliamps, I don't believe, it is getting the same exact reading from the battery source to the output of the coil that we get with the other multimeter, which is hooked up. We hooked it up in series. Right, and we didn't measure it with the amp clamp. So we hooked it up in series, and we got the readings of 470 milliamps input and then 457 milliamps output. That's pretty damn close to the same numbers that we see here, the same in terms of, them matching, right? They're almost matching, where we have just a slight loss on the output of the coil. That is interesting itself. So I think that, might tell us something as well. But at this point, let's just switch that number in our minds to 457. I don't think I have the video up, but I will be taking another video or putting another video up of the new current measurement.
15 to 16 milliamps before it hits the lightning thief, which must be using a little bit or wasting it, or I don't really know. Maybe we hook up more of a load and we'll see more of that translate. But this is 7.5 hours still.
So again, adjusting the load, in my opinion, I think is the way to fully tune the system. What I was getting into earlier, and I didn't kind of finish that thought, was I was measuring the frequency output of the coil directly on the output coil positive wire, positive negative wires, and I saw the frequency was around 15 kilohertz, right, before it goes into the circuit. Now that's the frequency of the coil. The frequency of the load is around 10 kilohertz. So I'm wondering if we can get that up a little bit, maybe increase the load frequency or the frequency on the output of the load to more closely match that output of the coil. Maybe if we might see more gains. Who knows?
Going strong hasn't skipped a beat on the fan area. The lighting for the neons did get a little dim though. The voltage increased slightly from 48 volts on the output to 52 volts, while the input continues to slowly drop and drain at about 0.003 volts per hour. So if this continues at the rate it's going, it will last another 50 some hours, about 57, 6 hours, something like that, which is pretty good, but that's right up against the line for 100% efficiency. We want...
So it didn't last that long. It didn't last anywhere near that long. It lasted only about 30 hours. My numbers might be off the calculations for the predicted efficiency of the system, so at 100% at least. So we won't really know until we match it with the we do the other test, but I don't really know what the efficiency is at this point. All I can tell you is that it wasn't, degrading the battery linearly. So it started out really, really slow, then it accelerated exponentially, and then it just kind of hovered around 6.5 volts. So yeah, it was a non-linear degradation or drainage of the battery. I guess that's to be expected. I really don't know too much about this kind of thing. Batteries are new to me, so but again, the amazing thing is that the system does have the ability to squeeze that extra energy out of the battery. So let's compare it. When we get the battery charger, we're going to compare it to what we see here and see what we get. Now I can tell you right now, we're not going to be able to power 5 of those neon lamps. So that's going to be thrown out the window right there. We'll test it and see. I think we need to tune the system a little bit more. I think we need a little bit more tuning
to see if this is getting extra than 100, the COP over 1. So it's going to be right up against the line maybe. But if it lasts longer than Saturday morning, we have a pretty good idea that we're getting a COP of at least 1 or more.
Yeah, so I don't think it was pretty good efficiency. I think it was pretty poor. I couldn't tell you exactly what it was, but my gut instinct tells me it's probably closer to like 60-70% efficient. So keep that in mind. Okay, quick update. We're going on about 13 hours now. I had to replace all 5 of these neon lamps because they all burned out. I'm not really sure why. They're supposed to last a long time, so something is causing them to burn out real fast. Unless they're just cheap, which I don't think they are. They're pretty decently made. So let's check the voltage here. Okay, so we have 12.24 volts coming out of the battery still. Let's check the voltage on the output. Let me switch it to AC. Oh, it's dropped a little bit. Look at that. For the first time, it's dropped in voltage. Let me just double check the connection. Maybe it's not secure. Yep. So for the first time, it's dropped to 43 volts, going from 52, but maybe that's because we adjusted the neon lamps. So I will say a caveat here is we did add different neon lamps. I tried to keep them the same color, but you know, let's take one out for instance and see what happens. Yeah, so that doesn't go up any. Took that out, put this back in. And it's interesting, this 5th neon, it doesn't light up right away. But watch,
really
in a few minutes it will start to light up. It's very weird. It's like a buildup. I think it's back EMF from these fans. That's my opinion. The fans build it up. I don't know. I couldn't honestly say. It might be something else, but very, very cool. It's obviously some kind of buildup effect. So we're going to check the current real quick while I have you on the video. We're going to ignore this current reading. Again, the current was wrong. We are going to redo the current video. But despite that, it still seems to be nearly maintaining the current with the other multimeter we read it with outside of the amp clamp. So that's pretty cool. For now, we're going to go to a quick intermission and get ready for the League of Extraordinary Inventors. All right, ladies and gentlemen, thank you for tuning in, and I'll see you in about 10 minutes.
Feel the pulse, divine sensation. Everyone needs just a little foundation. Feel the pulse, divine sensation. Everyone needs just a little salvation. Majestic moments in cosmic flight, holding on to the stars of starlight. There's a light within the dark waves, guided by echoes of ancient ways. Unify our reflection, with everything there's a connection. Feel the pulse, divine sensation. Everyone feels the goodness of our invitation.
Got an army of lawn gnomes.
There's a light within the dark ways, guided by echoes of ancient ways. Unify our reflection, with every there's a connection. Feel the pulse, divine sensation.
Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Friday. Welcome to the show. It is November 29th, 2024. Welcome, everybody, to our American brothers to the south. Happy Thanksgiving to everybody, and hope everybody has loads up on the turkey and in the
Nice.
festive season, and yeah, like we're less than a month away from Christmas too, so kind of a double whammy. Um, yeah, it's been a busy week. Yeah, a lot of people getting sick lately. I don't know, there's a lot of flu going around. Nathan, you weren't feeling good. My daughter and my wife and people at work are getting ill. It's like -2 degrees here in Toronto right now, and the wind is absolutely frigid. Like, just it hurts when you go outside. It's really, really bad. But we're going to warm things up tonight. Everybody, live chat is open. And also, I'm going back on afternoon shift after tonight. So it'll be 2 weeks I'll be gone. I don't know if Nathan wants to take over again like he did the last time. That'd be great. Yeah, so I'll probably pop into the chat during that week on my breaks and stuff. So I'll say hey, you know, and yeah. So
Absolutely.
we got Gerald in the chat. Gerald, I sent you a link. If you want to jump on for a bit, that'd be great. Oh no, hi. He had 2 teeth pulled today.
Well, that sucks.
That sucks.
Oh wow.
Yeah.
Do like Stephen Hawking. They have a machine talk for you.
Don't try to make him laugh right now because it'll probably make him more.
My coil is running efficiently.
Oh,
That's awesome.
oh, those are the worst. You got
Oh,
the front teeth. Oh god.
oh
Ouch.
man.
Oh, that's not a good day. I had my wisdom teeth out, and I'm telling you, the worst experience. My God, I hope I never go through that again. But anyways, we'll get into the show. Live chat's open, everybody. Nathan, we were talking off stage there about using iron. Maybe you can get into that a little bit.
Yeah, well, what I was finding, and I wish Gerald was here to explain this, he was always talking about a giant iron plate. So what I actually found out was the energy I'm working with, the Tesla coil, the wire down the center of it, it loves iron. And it doesn't like copper as much for distance. It likes iron. And I found it in a weird way. It's because those little cables that you get at the dollar store that connect everything that we all use, well, they're iron covered in copper. So if you take your magnet to it and put it on there, it'll lift it right up. So what I found is they're working 10 times better than the copper, that I've been using for other stuff. Even the coax cable, it went at 50 feet. It wasn't as good. It stops at 50. You have to coil it and run another 50. You don't have enough IRF in it. It dissipates too fast.
Oh,
It's about a 50-foot attenuation.
You know another good source to get an iron wire? It's Florist wire. They use iron wire.
Which one?
Florist. From the go to like a what do you call where they grow all the plants? Greenhouse. They use iron wire to tie up their plants. So you can probably get different gauges of that wire. You can buy them in rolls there.
But you can also get it to like hang your pictures on the wall. So if you go to the what is it called? Not hardware shop, the little hobby shop type of thing.
Hobby shop. Yeah.
Yeah. So you go there and they have all the materials and all that stuff. You go there and they have all that wire in there for that. It's also iron. So I don't know, but they sell it at the Home Depot and Lowe's. You can get it there. I buy it in so, but it liked that a lot better. And I've been testing it out and it seems to work 10 times better. By the way, I put it on lights in front of me and then went about 25 feet and put it up there, and it got two lights as well. Those coils seem to help bring in the frequency and get it honed a little better when you're talking about the RF in there. So that seems to work better. And I did an experiment today. If you don't mind showing it, Mike, I could present it.
Sure. Yep. Pop it up.
So tell me when you're ready and you got it.
I got it.
Trying to test, showing you how conductive this water and stuff is. Now, I don't own gloves like that with rubber in them, but I do have a string. So let's take a look at it. You know, just a normal string tied on there. No wire in it. Just string. You can see the end of it here, frayed. Now let's look in the jar. You can see the crushed granite at the bottom. The quartz. You can see the jar. Okay. There's my Tesla coil. Tesla coil is 6 feet away. If it pushed this far, man, I got a monster Tesla coil, so it's not going to be anything close. And my rodent coil puts out about 2 feet, so it'll be completely useless in this. Let's set it up. There we go. Get the top of that jar right there. Then I'm going to turn on this little light right here so I can see something. And we're going to get busy.
We're gonna see the Joker coil all nice and glowing.
Oh, I didn't put it out in the sun. I wish I did.
Oh, it's okay. When it's glowing, it's so beautiful.
Yeah. There's the light in the string. Goes up and tighten the string a little bit. Goes up further. That's no issue.
And it's not grounded at all.
That's pretty good, huh?
Awesome.
Yeah, that's pretty cool.
Yeah.
I have no issue with it.
That's a
And,
quite a distance.
and it's not even, there's no
I'm
grounding.
holding it by the string. They told me to use gloves because I was holding the tube. That string, let's go up. So I had to use a string. Getting a little less bright. There we are. See if we can get a picture of it from a distance. Either way, it works. So,
That's right on.
I mean, look, I'm not messing around here. This is what this energy does. There's no lies. Don't own a rubber glove, but we'll do it again. Hopefully the camera will pick up the whole shot. There it is, lit up. You gotta get it close to light it. There's no question about that. There you go. Goes out all the way up. Lights up. There you are.
Wow.
Just on a string. Waving around on a string.
It's almost you could see the light waves going through the tube.
Hopefully that answers a couple.
the little
dots or black dots.
Yeah, it looks like there's waves going through it or something.
It does look like that.
Oh, well, when I put the coils onto it, it does it.
Oh, that's cool.
Cool. Right on. Hi,
So-
Lulu.
Hi, everybody.
Hey.
Hello, Lulu.
Hi, guys.
So the one thing is I used the warm water like Gerald told me, and it made a huge difference. So
Why do you
Yeah.
think that is?
you know, I don't know. It may be the vapors in the air or something like that when it goes up a little higher, but I think it's drawing in amps and get the actual quartz heated a little bit, pulls in some amps and able to push some stuff.
So warm water, right?
Yeah,
What
kind of a
are-
trip, huh? It actually gave it another about 1.5 feet.
I wonder if you put boiling water, what would happen? Just, I don't know. That just came to mind for some reason or close to it.
What kind of water?
Like just near boiling point. I think that would really increase it.
I'll have to try that.
Put it on a hot plate.
Yeah.
That too. Interesting. Yeah, I'm gonna definitely look into some iron wire. I have a few ideas.
Yeah,
Boy,
Joe says the boiling water. Yeah, he would know. He's over there messing with a coil right now, putting the heat through it. So
yeah, it helps electrolysis. I know that. Philip was talking about that a while ago. Heat up
yep.
the water. Heat up the water, you get more action.
Oh, look at that! I've got actually a graph that actually shows a very very interesting graph. I'm just gonna share. One sec. What's up? Yeah, so that's when you heat the. Can you see my screen?
Yep. Yep.
So when you heat the water, um, you get you require less electric energy, like the blue line. You require less electric energy to create electrolysis, to create hydrogen. And when you pass 100 Celsius, then it becomes vapor, steam. So you still require some less and less electric energy over the temperature up to 900 degrees Celsius. And after 900 degrees Celsius, you come from factor 3 to factor 2.5, which is 2.5, which is 20%. So you gain 20% more efficient. You have 20% more efficient electrolysis process by heating the water or the steam.
You would think the opposite. It's kind of weird, eh? Because when you get heat, you get a higher resistance. Like in a motor coil, if it starts to heat up, it starts demanding more current, and that's why hysteresis is going on. But here, it actually throws that right out the window.
But the thing is that the bonds between the atoms are more fragile when you heat up the liquid or the steam. You know what I mean? Because they distance themselves. The distance is greater, so the bonds are more fragile. You know what I mean?
Yeah, definitely. I've always kept that in the back of my mind, and I was doing some anodizing there about a week ago, and yeah, I noticed too if you add more heat to that water, it really increases the rate of anodizing. So, because in essence, electrolysis and anodizing is almost identical. You have your positive side is the metal that you want to anodize, and the donor is your negative. So, say it's zinc or copper or whatever, and you want to do that. It's basically electrolysis, and when you anodize, it actually makes it really fast. It actually happens very quick. I was quite surprised.
Very cool.
Yeah. So yeah, I got a question for Gerald. Gerald, do you have your spherical coil running or?
Which one are you talking about? The one he always uses?
No, he said that working on it. Okay.
Oh,
No,
you talking about the hot water coil?
no the spherical coil. Nice.
Mm.
He says it's insane. Nice.
Yeah, I'll have to see that.
Now, I want to see your presentation you made the other day, also, Gerald. It looked pretty awesome.
I don't know. The more and more I'm seeing Gerald, or not Gerald, Nathan doing his experiments, it seems like he's starting to lean towards what Stubblefield was doing. I'm starting to see a lot because he's using the iron wire. He's creating a huge field. He's experimenting, getting, extracting power from the ground, and that's what Stubblefield was pioneer of. And I kind of see him going. I think you should start reading more up on Nathan Stubblefield. Pretty fascinating guy.
I'll have to write that down. I will.
Nathan, have you tried to putting like two coils at two ends of the room and seeing what happens? What would that like create? Would it amplify everything, or would it like cancel out things? Would cancel out, or
To be honest with you, I usually only run one at a time. I guess I'd have to try it.
wouldn't it be kind of interesting just to see what effects it gives?
What kind of cross fields we get? Is that what you're looking for? Yeah.
Yeah.
Being that they're on different power sources, yeah. I've done it where it's lit up many Tesla coils with the power, but not two different fields altogether.
Yeah, like you just see what happens. Like, I mean, with the lights, do they amplify? Do they not work? Other things start on. It would be interesting to know how that works.
Yeah, give it a try.
Right. But very cool. I think the range is now much longer. Much.
Yes.
Yeah.
Now that I'm learning what it's taking, because the ground has a lot more heat in it than what we think, and it has a lot more minerals in it, and depending on where the water table is, as soon as I can put all three together, if I had a well line, God help me, it would be everywhere. If you know what I mean, but I don't. So, yeah, I just have to deal with what I got and try to make something work.
And I think that's part of the reason how the pyramids work the way they did. They had these channels of water underneath the pyramids, these aquifers. And I think what Nathan's working on and what they were doing back then, very, very similar.
Oh, Gerald and I have how I say it's the same type of power, just like you have, Mike. It's just done in different ways. That's it.
Mm-hmm. Different methods.
Yeah. We're just taking different aspects of it and driving it in a different way, but it's definitely awesome the way it's coming out. So
yeah, and the effects are very obvious. It's not like something you have to really look for. You know what I mean? It's there, and you can see it.
Oh yeah, it's big. No. When I started lighting up that pond, man, and I started getting distance out of it, and realized what I was missing out of it to get the rest of it, yeah, it made it very easy to understand.
Well, the other thing too, I guess you don't live very close to the ocean, do you?
No, I live in the valley, so about
yeah.
40 minutes at the minimum.
Yeah, if you had access to actually make a ground right into the salt water of the ocean, because the salt water probably enhanced that effect even more.
Right? Oh yeah, I'd be pulling buckets of it along with the sand up and trying stuff every day.
I could just see you loading up your trunk, taking black sand and seawater. People give you a funny look.
I'm gonna get me one of those little swimming pools and just fill it with sand and water and light it up and have some fun.
There you go.
Be like a day at the beach, huh?
Yeah. Put a little rubber ducky in there too.
I might just get some rain gutters or something. Just see the distance I can get out of it.
Yeah. Well, it makes total sense. Like the copper buses that they were using at Bolinas at RCA, it was like miles. Like copper buses, like 6 feet wide in some points, and plates 30 feet by like 60 feet long, dredged right into the Atlantic Ocean.
You know what? Hold on. It just that I know why iron does it. Okay, copper slows down magnets, so any magnetism in it slows it down. Iron does not do the same thing, not in that way. It amplify your magnetic in there, so it's the opposite effect. So it works much better with the iron wire. That's why it's amplifying the magnetism instead of subtracting from it.
It's amplification. It's actually amplifying it.
Yeah, that's why you would use iron instead of copper. That's interesting.
Now, amplifying, but I think also radiating it out away, kind of like when a photon or light hits a mirror, and when it reflects, it gives distance. Maybe the iron kind of reacts the same way with radio frequency or energy. It's like, yeah.
Yeah, I think Gerald agrees. That must be why that Warden Cliff looked like mostly iron every time I see it.
Ooh.
You know what I mean? It didn't look like copper to me.
Yeah, you know what? Like the other thing with iron is you got to get the right iron, because iron could be a real bugger to work with, especially if you want to make a coil with it. It can be extremely hard to do it, but if you get the right metal, it's not so bad. I was saying before, like the florist wire. You get at the florist, they use iron wire. And that stuff's actually pretty easy to work with, so you can make a coil with that. You probably have to insulate it, like paint it or something, so there's a coating on it. So when you make your coils, it doesn't like short itself out, right?
Mm-hmm.
Or back in those days, they'd actually put a cotton sleeve over the wire and then roll their coils. Actually, Michael Faraday did exactly that, right?
Don't they dip them in beeswax or something?
Beeswax, or even just wrap it in copper cloth and wrap. Yeah, it was a tedious process to do it, but yeah.
Oh, do we have to
People don't
mind
know.
our own beeswax, or can we get it from somebody else?
I don't think it matters. It's just basically all it does is just create isolation. So when
I'm
you
kidding.
oh, I know. I know where you were going with that, and I tried to segue out of it.
Good save. Because that was a bomb.
Yeah, no more holes. I don't want to touch my holes or anything.
Okay. Yeah, let's get back on topic.
Lulu's just like you guys. Okay, where were we at? Yeah, just as long as you isolate that wire, just wrap it with cloth or cotton, paint it, varnish, shellac. You can paint that wire, let it dry, and then after that, you can wrap your coils. There's many ways of doing it.
Varnish a little bit.
Yeah, varnish is the most popular because it's the easiest to do, but you have to do the sections. The paint is kind of a tedious.
So the paint acts as an insulation?
Yeah, so when you're wrapping your coils, you're not shorting out each winding, right? Right.
Ooh, Sean was making 3D prints with the wire, it being very, very small in between each layer, so he can wrap his coils like like that. That with iron might work out perfect.
Yeah.
I'd give it a shot for sure.
We need to call up Sean and figure out who his 3D printer guy is.
Oh, Sean 3D prints his own stuff.
Oh, he does it himself. Oh, okay. Well, we'll call up Sean and have him help us out with that.
Oh, I can run that CAD just as fast. Trust me.
Oh, you can do CAD. Oh, can you modify a couple things for me then? Because I have a couple of things I need modified, and I don't know how to do it.
Modified the paint, building them new is easy.
Is it built? Okay. Well, I'll talk to you about it later if you can do that, or at least show me how to.
Okay. I can
Yeah,
do that.
you can get the educational or hobbyist version of Fusion,
Hmm.
and you can download that for free. And just
Fusion.
yeah, Fusion 360 AutoCAD. It's the easiest version of 3D CAD to use.
Mm.
I've been using it for years. I'm like a pro expert with CAD Fusion,
Mm.
and yeah, I've made some pretty cool stuff with it. And if you got a good
Yeah, no,
three,
that's going to be important because I want to design a magnetic rotary, and you can't really
yeah,
find that on. You have to custom make it. So.
Mm.
yeah,
You know what?
yeah, just
Mike's right in the comment. He said that they're printing iron. I have a roll of the iron filament here,
yeah,
Mm.
so I can test that for the RF in there. That might be
Yeah.
cool.
yeah. Yeah, you can buy the filament now, iron, and they got bronze, and what else they have? They got conductive carbon graphite. They got that. They have a lot of
Interesting.
different composites. So, yeah, yeah.
Huh.
I have some of the conductive carbon graphite. One roll costs $100, and it's only like 1 pound or 2 pounds. It's not
The
cheap.
carbon fiber,
No,
or graphite.
carbon graphite. Yeah, conductive.
Mm.
It's conductive.
Mm.
Yeah. So
Printers
yeah,
can
there's a
print
lot of
metal now. Interesting.
yep,
Yeah, that's cool. I didn't know that.
yeah, it's coming a long way. I worked actually at a company where they were using robotic arms, and they were actually doing. It would spray the actual element of steel, and they would hit it with a laser, so it would actually intersect
Mm.
right at the point of fusion on the surface.
Mm.
So yeah, we were doing some pretty advanced stuff, and yeah,
Yeah, these I seen a mechanical arm assembly device. It was like an industrial version. It was very capable of doing pretty much anything laser like cutting wise. Like if any angle, very very fast. It was very yeah, it was impressive.
well, they got robot welders, they got robot 3D printers now. It's
Mm.
getting pretty up there, as the computing technology gets a lot more robust. Now we got the AI,
Mm.
and you got the quantum computers. IBM's got a really big one right now, and oh yeah, just kind of segue for a sec off topic, but the quantum computers, when you look at them, they got these like networks of wires and all that stuff and coils and stuff. Know what I found out that was?
But
It's the cooling system.
Yeah, the cooling system. Yeah.
It's the cooling system. It has nothing to do with the computer at all.
Hmm.
It's a
Just to
cooling
cool it down. Yeah.
Yeah,
the cool part has nothing to do with that, huh?
exactly. It
The
has absolutely
radiator.
nothing to do. Yeah, it was the radiator.
And imagine if you can use some kind of like coil that would eliminate that heat issue. You know.
Well, what they want to do, see, the part of the reason why quantum computers work at the speed they do, what they're trying to do is super cool that chip down to absolute zero. And that's what those coils are designed to do, to
Mhm.
remove any kind of heat away from that chip. So I think
Yeah,
absolute
they
zero is
require
almost
superconductors.
400. Yeah, well, that's when it goes into superconductive state, is when you get to absolute zero, which is minus 400 and something degrees, 467 degrees, or yeah, it's cold.
So
So
that's not
that
actually theoretical anymore. You can actually get to absolute zero now.
oh, you can, but it takes
Okay.
a lot of power to do that, right? It takes
Yeah, because I
very,
know for a
very
while it wasn't possible because we didn't have the technology or whatever. But now we have reached absolute zero.
well. You can do it with liquid nitrogen. You can do that with a magnet and float it. It'll float over the surface, right?
Mm.
That's why you're able to get that anti-gravity effect when you cool a magnet down to absolute zero, which you can do that with
Oh, so
liquid
that is
nitrogen.
absolute. Okay, no, I was getting wrong information then. Somebody told me that was near absolute zero, not absolute zero.
Well, it's in the superconductive state. And that's why that magnet's able to hover above a steel
Oh,
surface like that, is because of that.
is it like a range or is it like a specific like threshold where it hits this number and it just snaps in?
I I really don't know the exact number. I would imagine it have to be minus 40 C to do so. I don't know the exact number when that effect actually takes place, but I'm pretty sure because it was close to that.
Yeah, it's probably some kind of threshold effect.
Just a little snippet there.
Hey,
I wonder
Lulu,
if you
I
can.
just-
hey, Lulu, I'm going to Austin, Texas on Monday morning.
You excited?
Yeah, it's gonna be awesome. Is it hot over there?
Like right now it's about 58 degrees. 58
That's
degrees.
cool.
58. Yeah,
Yeah.
that's kind of cool.
Phil, did you get your cowboy boots?
Yeah, I'm gonna dress like the Back to the Future. You know when
Lulu's gonna meet you at the airport, right?
If you really want me to come, I'll come. It's 2.5 hours. Not a big. I'm in my car, like listen to a few songs. I'm there. It's, I'll probably make it like in 2 hours, a little less.
yeah, I'm there from the second to the fifth.
Okay.
I'm leaving the sixth actually, but yeah, we can maybe go grab something to eat if you want near the JW Marriott in Austin, Texas.
I'll email you my number. How about that? That way we could, we'll plan out if
Yeah.
Yeah.
All right, sounds good.
Well, yeah, because I'm excited about your project. I want to know firsthand, what's happening there. Yeah.
Yeah,
Definitely.
so if you guys don't hear about me anymore, then you know what happened to me.
Lulu abducted you.
Yeah.
You know, today I was thinking to myself, I'm like, man, these humans keep me busy with like all their holiday stuff and their cooking.
Yeah. So
Actually, you know what would be a no? I thought it would be a cool experiment. Buy some dry ice from the grocery store. I know at Walmart you can buy it in. It comes in a box,
Mhm.
and put the dry ice right on the Renegade's coil. Super freeze my coil.
Yeah.
Yeah, there you go. Superconductor right there.
That'd be cool.
oh yeah, you can make a superconductor with dry ice and
Yeah, super freeze my motor coil.
And with all the fog, it would be very atmospheric if you recorded a video.
Put it like flashing lights and stuff.
Yeah. I mean, the Renegade's built for that. It already glows in the black light, right? So.
Yeah. Yeah, that'd be interesting. I should do that. That'd be a cool experiment to see if I get a better performance with a super cool coil.
I'd be interested in looking at that.
Yeah, because I know dry ice is what minus 200 something degrees Celsius. Ooh, interesting.
That would
Get me
increase
thinking.
by far,
Yeah, reduce the amount of current need to run the motor.
Huh.
You gotta like have enough to make it last where you could actually measure it, to like
Yeah, you would have to build in some kind of box, but implement it so it would work with the motor. You know what I mean? Kind of put in maybe like a plexiglass box that's insulated that would hold that energy in.
Why not just do it to your coils?
What's that?
Why not just do it to your coils?
No, that's what I want to do.
Yeah,
Yeah,
just make a casing for it. Yeah.
Yeah, that's what I'm talking about. Yeah. Encase it and then drop the dry ice inside. Wait a few minutes and start it up to see how it works. Interesting.
With this type of energy, I don't know how far down you have to actually go to get it to superconduct because it's already pulling on the negative side. You know what I mean? So you may not have to do any more than put it in mineral oil to get rid of any surface heat.
Right. Yeah, any kind of cooling, I could see a good effect happening.
Yeah, just chill your mineral oil. Try that first.
Yeah, or just
I also do of it.
Hmm. That'd be really interesting. Really got me thinking.
What would liquid
Experiment coming up.
what would liquid helium do to it?
Liquid
Is it
helium?
Oh, I
not
don't know.
would
No,
not
I would I would probably work with dry ice because it's readily available. You can literally buy it at Walmart. It comes in I think a styrofoam container, and you just got to use a good pair of oven mitts to handle it, or a pair of tongs, and just set it right on top of the coil, and just let that coil freeze, and you'll see it frost. Hmm. And if the inductive reactance, yeah,
that would be
that
really cool.
might help. Hmm. Ooh. Now I'm thinking that could be a very good experiment to show.
Yeah. Yes, it would.
Even for your experiments too, Nathan. Have you ever tried supercooling your Tesla coil?
No, I haven't. No, it needs the heat. It's got to produce the heat on the outside. Well, I guess I could try it.
Nathan's already super
Yes.
cool.
So when you heat the coil, the resistance increases. Is that it?
Yeah, the energy coming out of it goes further when you heat the inside of that coil.
Yeah.
So the hotter it gets in there, the further it pushes out that radiant energy.
Yeah. But the electric resistance is increasing as well.
Yeah.
Yeah.
So in order to cool it, you have to go for a bigger diameter coil and a thinner rod going down the center in order to get it to cool, or else you're working on the hot side of energy again.
Yeah. Yeah.
So, which by the way, Ian was doing, he put 6 rods down his, and he could pull off 300 volts on each one of them through the Tesla coil doing that. But it's at, I think he was getting a half a milliamp or something like that out of them. So he's going to have to convert and make sure he doesn't lose it all in heat.
Guys, I'm just going to go for a quick smoke. I'll be right back.
Yep.
Okay.
Wow. I don't hear that TV anymore. Wow.
So
Quiet.
were you guys you guys have 2 days off for Thanksgiving? Is that it?
Oh, I don't know. I haven't worked in a while, man. I retired a long time ago.
Oh, you retired. Okay. A
Yeah.
long time ago. Geez. Sounds like you retired when you were 25.
More like 35, but yeah.
Oh yeah.
Been
Wow.
retired for a long time, man.
You won the lottery or what?
No, I wish. I broke my back in several places.
Oh,
I had to get it all put back together. So,
oh, I see.
yeah, once I put it back together, nothing works the same. That's why they called me the old man on my channel, because I walk around like I'm 70, and I'm only in my 40s. So,
Oh yeah. Yeah. So yeah. Yeah, I'm trying to retire, but the legal way. But we'll see what happens. Right now, it's it's the opposite for me. But I really need to sell my stuff, my software and stuff like that. So hopefully that's gonna kick in. The sales are gonna kick in soon. We'll see.
Phil, you're gonna be sipping Mai Tais on a beach somewhere soon. Like with the technology that you have, you're gonna be doing fine, man. I have no doubt.
Yeah, but I'm doing more than what I'm saying here on that show. I'm doing also programming. I'm programming autonomous missiles, and
Oh, so
that's
you're
very
oh,
doing all sorts of stuff. Oh, I see.
yeah.
Nah, I see how it comes out now. It was a ruse, what you're telling us, why you're really going to Texas. Now we know.
He's a jack of all trades.
That's why I'm always tired, you know. But I think it's worth it, you know. My goal was to retire at 35, but I'm 47 right now. But hopefully before 50, we'll see. I'm gonna aim before 50.
Very cool.
But what I'm gonna do when I retire, I'm probably gonna see some beach. It depends if California they change their governor. Maybe I'll go there. Otherwise, I'm gonna go to Hawaii or something like that.
There you go. Yeah, it won't be freezing like it is now for you. It's
I'm fed up with that shit.
56 degrees Fahrenheit out here in California. So it's like summer for you.
Yeah.
It's nice.
Exactly. When I remember some people were saying, I used to live in Pacific Beach in San Diego, and I was walking around with some people, some girls and whatever. They were saying when there's a breeze from the ocean that it was getting cold. It's like, what do you call that cold? It's like you haven't been to Canada yet, and
Yeah, no kidding.
yeah,
It don't get anywhere near as cold as you guys got it right now.
yeah. But it's amazing. People in California, they don't get out of California that easy, huh? My friends, they never leave California. They don't get out. It's like I'm trying to even Texas. I'm trying to bring them to Texas, and they said yes, and then they changed their mind. Oh, I can't go. I can't make it. Blah blah. Blah. The worst the east most they've been at is the Vegas, but they don't go farther east than Vegas. That's pretty funny.
Yeah, in order to fly out of California, your driver's license has to be a special license. They changed stuff there. So if I wanted to leave California, I have to go over to Arizona and get on a plane there because
Oh, yeah?
if I don't want to sit in the DMV for like 2 hours. And that's kind of one of the problems. That's why nobody wants to do it. Then it's going to take me another couple hours to get a passport. It's going to be like a couple day journey just to get to leave California. So, yeah.
So you gotta go to DMV before leaving California.
Well, months before, yeah. You got to go there and switch your license because they switched it on us. It used to be normal. Now it's not.
Oh yeah?
You have to have this special ID license, like they're going to track you.
Are you kidding me?
No, I'm
Wow.
not.
Are you serious? You have to have a special license to leave the state?
Yeah, they changed it as you can't use your regular driver's license.
What?
Yeah, it's a photo ID of some kind of weird kind. My daughter's got one. I don't.
That's messed up. That's messed up.
Well, why
Well, we live in
don't-
California. It's, you know,
Yeah, you guys have a bunch of weird laws over there, huh?
Yeah,
Yeah.
and if you're an illegal immigrant, they give you a driver's license for free.
no, they'll take care of it. It's not that. It's just paperwork and time. You know what I mean? That's about it. I think you have to jump through a few hoops like everything else in California. So,
State, like just for like if you want to go on a vacation, you have to go get another like piece of paper just to leave. Okay, what happens if you leave and you don't do that?
well, it's fine if you leave the state. It's not that. It's getting on an airplane.
Ah, talking about an air. Okay, never mind. Never. I thought like just you could drive.
No, no,
like-
no, no.
Oh.
Leaving the state's fine.
Okay.
I can leave the state anytime I want. A couple hours in the car and I'm out. You know what I mean? But yeah, it's
Oh.
certainly a different place here. It's like a different world than the rest of the United States. It's like every restriction that they can get by the Constitution, they put it in place. And then half of them get rejected when they get to the higher courts, and then we don't have to suffer that stupid law anymore. So,
You know, Texas, we have like our own constitution. You know that, like they
oh, I know. My
There-
brother moved to Texas for that reason.
yeah, Not all of it is good. I'll tell you that, but most of it, most, like a lot of it, when you cross the United States Constitution. Now, who wins if two things kind of, always have that kind of with the U.S. Constitution supersedes? I don't know.
I'm sorry, I couldn't hear you though that well.
I was saying how the laws here would, like, if two laws cross, which one do they take? The real Constitution or the Texas Constitution?
Hmm.
You know?
Yeah, in California, it's theirs.
It's what?
I said in California, they screw you with their constitution more than they ever would with the federal one. I don't think they read the federal one in California. To be very honest with you, I don't think they do. They only read the California one. So if you're ever pulled over, put on a dress, and you're good to go, you know what I mean? They'll let you leave because they don't want to arrest you. But they don't want it shown in the court, I guess. But yeah, California is a weird state, man. Weird state. Like, if you're a bum on the street and you do something wrong, they leave you alone. But if you look like you have some money, then they arrest you.
Yeah.
So it's a strange state. Like
So
they literally map out where people poop in San Francisco, where all the homeless people poop everywhere. They literally have maps for it.
Really?
I've
been to San Francisco. I don't recall seeing that. That's weird.
Hey, we can invent a GPS to avoid the poop.
Yeah,
it was fine before, but the Democrats, they all screwed up. They put in place the sanctuary cities all over California.
Now they're gonna fight them there too. So yeah, it's gonna be bad. It's just gonna get worse. We got a guy with a nice smile, nice hair, and absolutely nothing between his ears. Like literally, he's got to go to the tire station to get air put in there so it's filled up. He is not very intelligent.
Yeah.
I think most people in government have that issue already.
Yeah. Well, I'm sorry, I don't want to bring politics into it.
It's a big thing right now, especially what's happening overseas, and it's just getting dire out there.
Oh yeah, with Russia and Ukraine.
Man.
Oh yeah.
Oh man, they're playing with fire with this stuff. I've been watching a few other podcasts, and I watched this guy Ritter. His name's Ritter, and he's amazing. He knows what's going on, and the U.S. government is playing with fire, man. Literally.
Yeah. Joe Biden is like, if I go down, the whole world is coming down with me.
Yeah.
Oh yeah.
That's basically it. That's exactly what he did when he allowed those strategic medium range missiles to go to the Ukraine. Oh man.
I have a question. Didn't he, like, before the election, say, like, okay, he's handing things to Kamala or whatever her name is, and why did he come back? Like, all of a sudden, like, I thought he kind of stepped down, in the meantime.
I personally think Obama is still pulling the strings behind the scenes. I really think he is.
Of course he does, because he's tied with Diddy and all these Hollywood's elites.
Yep, you got that right.
Well, the best thing about Obama was his oratory skills, and just giving his speeches. The worst part about him was his policies. They all sucked. So if he just gave policies instead of talking, then I could see why we're screwed.
Yeah, he talked like he was for working class policies, but at the end of the day, he was just another neoliberal.
I think the only thing that's holding Russia, like, really starting World War III, it's just they're waiting for Biden to, like, step down, and because they know Trump is going to be next, and Trump and Biden are on good terms, as when Trump was in the office, And I just think he's just like telling him like, hey, get this guy out, off the seat as soon as possible before, these missiles hit Moscow. You know what that means? Like, it hit Moscow. It's, that's Putin's home. It's like, I don't know, man. Like,
See, the biggest mistake that the U.S. did was pull away from the INF treaty. Even Putin said that. That's when the game changed. Because of that, that's when the development of that new hypersonic missile went into full swing.
Remind me again what the INF treaty was.
Well, basically, they had to keep a border away from Russia. There was a sovereign area. So what the U.S. started doing, they started putting missile stations in Poland, Germany, and I think there was one more country that eludes me right now. But when that happened, and then the U.S. decided to pull out of the INF treaty, that changed the game. So now basically we're in the midst of another Cuban Missile Crisis, an arms race, and right now Putin's it's
they were also supposed to not bring NATO into other those countries around Russia.
That's right.
And they did, exactly. And that's what's violated. I mean, think about it from Russia's side. What are they going to get to their ports? Their ports are in Ukraine. So, of course, they're going to go into Ukraine and take them if everything's going to NATO. They're not going to let that strategic asset go away. I mean,
that makes
sense. Everybody should have known that. It's pretty easy and obvious to see.
Yeah, because you're closing in on somebody. They're going to they're going to defend themselves.
Well, yeah, they're trying to protect their sovereign borders. And now you got a NATO country right on their doorstep.
Yeah. Well, like Nathan said, it should have been obvious.
Oh, it was. They knew what they were doing.
Yeah, exactly.
They knew what they were doing. They've been doing it for years. They've been doing it since the early 90s. So every time they keep pushing more and more countries into it. And even last time, I think Putin said, well, why can't I join? Or, I mean, he would consider it to join NATO. But then it goes against everything that they want. They want him done. And he's like, well, I just want to get along. And then now they're going to force him into a bad situation. And you start doing that, and he's got allies. And then it starts a whole pile of what going on.
No, that's true.
The latest I heard, if let's just say, quote unquote, shit goes down, he said he's going to take out the base they have in Poland, and he'll take out the base that they have in Germany. And he says,
yeah, I saw that.
He says, you will not leave it. It will be ash.
Yeah, well, how fast those missiles he's got goes, then
the hypersonic missiles.
Mach 10.
Yeah, in that speech 10. He said, I don't want to use nuclear caps or whatever, but he will.
You don't need nuclear weapons.
No,
anymore.
He's got the hypersonic ones. Yeah,
kinetic weapons, man. They're almost just as lethal.
The chemicals, the chemical ones are as dangerous.
Do you think that's using any kind of scalar or maybe anti-gravitics or anything like that? Anything unconventional or fringe?
It's pure mass and velocity kinetics. Yeah.
So it's just traditional.
Well, they're bringing them up to altitude in the sky.
But they're so fast that there's no way to destroy them.
Yeah, you got a missile that's traveling 2 kilometers a second.
The only thing that you can do is build a force field at that point, huh?
Yeah. I don't even know about that.
No. Too much velocity.
You're way better than bunker busters, I can tell you that.
Oh, yeah. You can imagine if the warheads, say, weighed 2 tons going at Mach 10, hitting you.
Well, I'm talking about maybe like, Phil, you said you had some kind of like protection technology that could potentially, like act as a boundary. Do you think something like that would work against a hypersonic missile? Not like at close range, but like if you extend it, maybe like as a bubble.
Yeah, it would, because the speed of an electric field is faster than the Mach whatever you want, you know. So the speed of so all you will have to do is ionize the missile so that it becomes charged, and as soon as it's charged, then you block it with the force field,
So you could
with
have
the
two bubbles, an
repelling.
ionization bubble and then a smaller bubble inside. That's the boundary.
Yeah, exactly.
Hmm.
It's possible to do it to have a real force field, but the real force field would require astronomical electric current. But but other than that, we can manage to make one using 2 million amps, something like that.
Hey, Philip, if you got a kinetic weapon, you know, going 7,500 mile per hour, when it hits something, is that going to create an EMP
Oh.
An electromagnetic
pulse?
bomb.
Pulse, yeah.
Yeah, most likely, yeah.
Wow.
Wow. That's crazy.
Yeah.
Fly any electronic within, I don't know, miles, maybe.
Yeah, you'd have to shield for that.
Yeah, Faraday cage it. You'd have to Faraday cage yourself in a bunker somewhere.
Yeah. Wow.
But
Well,
the
at least we
repelling
know it's
force, the repelling force of the force field is pretty good. It's pretty strong. It's not like two charges that repels. It's like an extension of the atomic force. You know, you put the atomic force at a greater scale, so the repelling force is very strong.
right. They call that the strong force, or is that the
Yeah,
weak force? I forget.
the strong
The
nuclear
strong
force, but at greater scale.
Hmm.
So
That makes
that's what
sense, though.
yeah, that's what the force field is, and it's possible, and I'm sure. I haven't tested it obviously because I don't have 2 million amps here, but the U.S. military can easily test that.
Hey, Philip,
Well,
here's another question for you. If a missile coming at you at that speed, if you were able to hit it with a focused EMP on that missile, would that do anything to the missile? Could it disable it or cause a malfunction in it?
Well, it's gonna maybe it can malfunction, but the object is still going at Mach 10. You know, the
Yeah, yeah,
kinetic energy. It still has kinetic energy,
right.
so
Yeah,
that's gonna create a lot of damage
you're,
regardless.
you're pretty much SOL on that one.
But the force field can definitely stop it if you ionize the missile. Every projectile. The thing is, every projectile is made out of metal, and all metal can be ionized.
Yeah, it's
So
gonna have it's gonna have a plasma field around it. That's what I could see it. It's having a plasma field going around it as it's going through the atmosphere. It'll just intensify.
well, the plasma field, it's hard to manage. You know, it's how can you tell the plasma field uh, to be at a certain distance or certain strength? It's hard to manage. You know what I mean?
Yeah, it sounds
Whereas,
like
Yeah.
it's a pretty terrifying weapon when you think about it. You imagine if they had a missile that did Mach 20. That's just
well,
insane. You would actually not even need a darn warhead on it. It could just be a lump of steel.
Yeah. Pretty much.
apparently, yeah, Mach 20 is reachable these days, but I'm not gonna name names. But they know how to go faster than Mach 20 already
Wow.
with projectiles and missiles and things like that.
hit like an asteroid, it'll create like
Yeah, could you imagine what that was like? The one that wiped out the dinosaurs?
Yeah, and
not
it's
as big as
it
that.
wasn't a nuclear bomb. It was just a comet like slamming on the earth.
Yeah,
You know.
yeah.
Like be as big as that, really? No.
Well, when you get to that size, that's an extinction level event, and that's
Yeah, no.
just one.
I don't
That's just one hit.
Yeah.
Yeah. Wow. That's bad. It's just all
That's
bad.
that's like science gone crazy right there.
I, man, they would ever I think they just like they talk. They like to talk. But like for real, like major catastrophic, I don't think anybody's that stupid. You know, I'm, we're talking about
Well, you
like
never know.
no, I think they've learned their lesson with the
I
and
don't think so.
you know I think I don't know like we
Great nations have fallen before. Look how long. Like perfect example, the Egyptians. They lived in peace for like 1,500 years. No wars, no nothing. They didn't even have an army. And then out of the blue, who comes tromping in and wipes
Alex
them out? Right?
Alex was it was it Alexander or Julius? I don't know like
The Greek Empire, right? They all came in and devastated. Genghis Khan's another one. Look at what Genghis Khan did. He was probably the largest mass murderer of all time.
yeah, but you're talking about the ancient times. I'm talking about modern.
No, but the magnitude of what they did, it's just, fighting a weapon, fighting with a weapon, from a stick or a bow and arrow to a nuke or a kinetic weapon. It's just a type of weapon is the difference.
The world existed like there. I think back then, like in the ancient times, it was a different philosophy, and they didn't they didn't respect each other, to a level like we still have to a level of respect the other nation to a level
We
that
still haven't really changed. There's
Yeah.
still wars. There's
We're
still
still the
wars. They
same.
haven't changed.
but still, when it comes to nuclear war, it's a little bit complicated.
Well, pretty much everybody knows if it goes nuclear, it destroys the planet.
Exactly.
You might not initially die in the explosions, but you're going to die from the radiation fallout, famine, contaminated water. The list just goes on and on. So you might not initially die from the explosions, but it's the aftermath. And then you go into a nuclear winter, which, all your crops are failing. The Earth's temperature goes down. It's just a cascade of bad that happens afterwards.
So do you
Right?
still think anybody's stupid enough, to really do it, or do they just like to play those word games, threatening?
Well,
You
they're
know?
playing political chess, is what they're doing.
Yeah, but
And
I don't think anybody that would be that stupid to take take on
I
that
think
level.
Iran would if they had it.
oh yeah, I think certain nations would be more eager to pull the trigger.
You don't think they know the damage that it could cause and it could harm them?
I don't think they care. They have one goal to wipe out a certain, individual, and that's it. To wipe out their race, and once they're done, well, that was their goal. I mean, they would literally be that dumb because that was their goal. Their goal wasn't survival. They've already proved that.
Hmm.
I mean, they're sending out, people to blow themselves up. They kind of tells the story of where they're at, huh?
Yeah, it kind of tells you what the mental state is.
Yeah, like
They're rel-
the guy
they're-
I'd like less around that trigger is the guy that sends people out to do that, if you know what I mean. So we'll keep
Yeah.
that guy away from the button.
Yes, exactly, at all costs.
Yeah.
But yeah, it's amazing. They say After World War III, if it ever does happen, the next war will be with sticks.
Yeah.
So,
Yeah.
All right, guys, I got to get out of here. I got to go pick up my son-in-law from work.
all right. Thanks, Nathan, for jumping on. And next week, I think, Nathan, you're going to take over the reins for the show.
Yeah, I'll take it on again, and we'll do it again.
Right on. And I'll jump on my breaks and say hello to everybody in the chat there. Chat's doing great tonight. Live chat's open. We're going to go live again on Nathan's channel at Old Man Builds. Be sure to log into his site, and you'll be able to watch the live stream next Friday night at 9 o'clock Eastern. And
Friday, right?
Friday night. And it's 9 o'clock here. What time is it in California? It's
it's 6 o'clock when we started it in California. Yeah, so it'll be the same time. I'll do it at the same time.
Right. Awesome. Okay. Thanks, Nathan. Have a good night.
Right on. Have a great night, guys. Thank you.
Cheers.
Take it easy.
All right. Cool. All right. So it's disturbing. I've been following the geopolitical situation. It's like, okay, let's say hypothetical scenario. World War III hits, society falls, we start rebuilding. Now, does society go on the same path as we did before? Or are we going to change our ways and start bringing the Tesla technology to the forefront where that could power the world? Because Tesla has himself said that the bankers and the power brokers control the world in this century, but the next century will be mine. If there's any truth to that statement, I think it would. Because
probably. If the way of the bankers leads us to extinction, then hopefully the next generation of humans will be more collective. But I think our brain right now is very limited. Like we tend to we easily tend to subdivide and flag people we don't know as enemies and things like that.
Right.
And
yeah.
We have a very, very, very short range vision of things, but maybe the next generations of beings will have a wider range, because the Cro-Magnon kind of derives. We just barely got out of hunting,
Yeah.
Our ancestors, they were hunting in woods and stuff like that to survive.
I think it's going to boil to the point where, if a catastrophic event like that happened and 60% of the world's population gets wiped out, are we going to follow the old traditions? Are we going to say, no, we scrap that because it destroyed our planet? Let's rebuild and have different visions and not subdivide each different cultures. One's good or this one's good. We're all on this planet together. We all have to get along. Obviously, the generation before us didn't get it right and blew up the planet. Let's don't go there again. Let's do things right. Let's go in the proper direction. We know these free energy devices exist. A lot of technologies that would clean up our atmosphere, make us more productive, have enough food for everyone. Poverty would be a thing of the past. But for something good to happen, something really bad has to happen first.
Yeah.
And I think we're getting close to that.
But it's the same thing. It never ends, the stereotyping and all that stuff. It never ends. Yeah. You have all the Russians are bad. So now I'm here in Canada. Canadians are now we tend to stereotype between Canadians. Oh, you have French and English, and between French, oh, this guy doesn't play hockey. Well, so he's an idiot because he doesn't play hockey. You know, it never ends. It never ends. We stereotype, you know, at all scales. So that I don't think that works very well. And I think the next generation of beings will have to,
Get over that. Yeah, they'll have to get over it if they want to survive.
yeah, they will need to require a wider visions of things because the universe is huge, and if we can't agree on our own little street, then you know we're not gonna get anywhere.
Yeah, exactly. Just learn from the old mistakes. Don't make the
Exactly.
same mistake.
Yeah.
Obviously, you know, we haven't thought about. There could be something from outer space headed our way that's going to wipe us out, and we wouldn't be able to do a thing about it. But until that happens, we got to get along on the planet and coexist with each other because we have this one little planet and it's very fragile, and something catastrophic happens, like what happened to the dinosaurs 65 million years ago, or do we commit suicide by wars? Right? It's
Yeah.
like, take your pick. I would rather take my thing on, okay, if a comet's coming towards us, I would go for that option because chances are it won't happen in my lifetime, but you never know. But I would rather go for that option than the being the homicidal, destroyer of the planet, right?
The
Yeah.
problem with our society, they think horizontal. They don't think vertical. You understand? There's a like horizontal thinking and there's vertical thinking. We think of just what the land that we're on and the surface of this, but science is also a vertical path too. And if we don't start
Yeah,
thinking,
yeah,
along
I know. Yeah,
line,
the
it
science is.
you know go
Sorry, go ahead.
no, go ahead.
Uh, you're exactly right. I think right now we have the same problem with academia. There's no real science being done anymore. It's the same old science being rehashed over and over again to all these college and university students going to get their papers or the BAs or their engineering or whatever it is. It's rehashed old information. They haven't progressed. There hasn't been any kind of technological progression happening. The only time there has been technological um, uh, progression happening is when you start working for a large institution like, say, Lockheed Martin or Skunk Works or Raytheon or any of these aerospace companies that are doing science. But doing that kind of science should be also being happening in the institutions, the colleges and universities, and college notes being updated or university notes being updated. None of that's happened. They're reading papers that were done 100 years ago with no, like, after Steinmetz died, that was it. Electrical engineering, real electrical engineering, died. It stopped. It stopped in 1929. It was over. So we've lost what, almost, well, 100 years, almost 100 years.
Did you
So
the current academia, its education level is meant for people to become just as part of a working class, not never inventors, never anything
well,
at the box, just to kind of fit into the
right,
little cubicles that they've already made for them to sit in.
right. They create the religion. It's a religion. They created a religion that this is what it is. You're not allowed to challenge it. The only time you're allowed to challenge things if you're actually a well-known physicist, which is wrong because there's a lot of people like myself or Philip or you or Nathan or Ben that have great ideas that kind of step out of that box or go over the line and saying, no, maybe it's doing it exactly the opposite way, right?
Yeah,
So,
the thing that was difficult to understand in my case is they don't tell you the academia doesn't tell you what's wrong with your paper. So you have a paper, they don't like it, but they don't tell you why, or they're very vague, or
right. They
you know
don't. They don't even. Yeah, they don't even want to touch base on it. They don't want to recognize even your question that was asked.
yeah, because it's the same thing again. I was talking. I'm not gonna name names, but I was talking to a PG, and you know there's a Sabine Rosenfeld and Dr. Unziker. They post videos. They criticize a little bit the mainstream. And I was talking to a PhD, and I'm not gonna name names, but you all know him. Um, he said, "Oh, the Sabine is not a happy person, so she went down the mediocre path." So they they already they don't even listen to people against the mainstream at all. They
Yeah.
already stereotype them. You know,
Yep.
they don't even bother listening to them.
Yeah,
So
because they don't know how to think out the box because
exactly,
because they're part of that religion, and that religion is what feeds that institution money. It all goes back to the money thing. If
yeah,
they go under a certain doctrine, you get your money. You go outside of the doctrine, you get your fund pulled,
exactly,
right?
yeah.
And it
That's
happens
exactly what it is.
right.
They are puppets.
Mhm.
They
Yeah,
are
puppets.
truly puppets.
Yeah,
Yeah.
puppets of the scientific religion. And the scientific religion, there's a lot of things out there that can challenge pretty much everything.
Since
Relativity,
But
general
you know,
relativity.
like we also play into this. Like Mike, you've got children, right?
Mhm.
And I mean, at one point, you do want them to go to universities and colleges and get a formal education. So
Right.
regardless, even if we disagree that they're still like on a level that they should up at the science a bit, and don't, but we still kind of put our money into this kind of whole thing when
Yeah.
it's no, there's not a way around it. Like it's a
Yeah.
it- I would never not tell my children not to go to school or get a formal education. You get it? Neither would you. Neither would any parent. And so
Yeah.
spending
The,
money to fund to pay these people to be in
right.
those.
Yeah. Like, the education they get, it just gives you the basis of everything. There's so much more to it. You know what I mean?
Yeah, oh yeah.
Learning your electrical technology, plus minus resistance, Ohm's law, all this stuff. That's fine. That's relevant stuff. But there's a point where you have to expand. There's no expansion. There's no, oh, let's segue down this way in theory, or let's segue into another area, like saying, like defeating Len's law. They would never do that because they've already written in the religion that Len's law can never be overcome, which is totally wrong. It's because they haven't come up with a novel way to do it. They say, oh, because it says it in the book, that's it. It's holy and you don't challenge it. That's where science went wrong. And that's where
Exactly.
I think that's where science has really stopped. I don't
Like
Yeah.
think that there's any
they
science going
they're
on now.
on already experimented theory.
Yeah, because they're always living within the confines of the theories that have already been done. You have to go beyond that, and they don't, because it's a very tight knit community religion of science. And honestly, I really honestly agree that science has stopped. There is no real good science going on
Yeah,
other than
I agree
inventors.
with you, but I agree with you and 100%. And But the good thing about it is, since 99% of mainstream scientists are completely useless, that gives us the chance to make it better. You know what I mean.
Yeah,
That,
it's
that gives us a chance to be with you guys tonight and create something new.
yeah, in a way that me, you, Nathan, all the guys that we talked to, we're all kind of like renegades. We are going against
Yeah,
the grain. We're
exactly.
renegades, and
Yeah,
that's why I named the renegade because of that. It goes against all the religious beliefs in science.
yeah. It's not a religion; it's a cartel.
Yeah, depends how
But
you want to look at it. Yeah, cartel, religion, whatever you want to call it. Yeah, and that's why I named that motor the Renegade, because it runs completely different than a DC or an AC motor in every way. It just runs on a different principle,
yeah,
completely the opposite of what a motor is.
yeah, exactly, and
And most science can't handle that.
yeah, Gerald. Yeah,
Yeah,
I can't wait for production on your Renegade, and we get to make all the little cool things with it.
but
That
you know what, Lulu? The thing is, the device is not rocket science. It is so friggin' easy to build. It it's just people didn't recognize what they were looking at. It's like, you look at something, you say, "Oh, this is a mouse," Oh, but is it really a mouse? And then you have to start figuring it out. So the same thing with my Renegade. Everybody thinks, oh, it just creates, magnetic field, pushes the wheel around, and that's it. No, you got to go way deeper than that. And why I use the switching system the way I use it, and why I use the transducers in it, and how it amplifies the power. And people don't understand. The second you release a connection from the circuit, you make it open, the current draw to the system goes to zero. That's why I'm getting 500 to 1,000% efficiency on my motors. Like the little Renegade last week, I did a test. I was getting, I worked up the numbers. It came up to 487% efficient.
wow.
Which is incredible. And I've had my motor as high as 1,500% efficient.
I mean, do people understand they could like run their little crypto farms with using this device for free?
Yeah, and charge your batteries,
Yeah, that's it.
charge your batteries and keep your CPUs, GPUs running all the time, or ASICs or whatever you're using,
Yeah. Like you put a coil to activate your to power, like the Renegade to like man, it's endless. The possibilities are endless. It's just you have to know how to connect the Lego parts.
Yes.
Yeah.
But sometimes it's like you build a device, or like some fantastic device lands in front of you, and it works, what it can produce, but how does it really work? That is the big question. I'm the type of guy where I like to build something and see how well it works in the end. And then I noticed that this thing was getting abnormal amounts of efficiency. So then I had to back engineer something that was already built and figure out what was going on inside this motor for it to happen. What were the forces involved? What was the science involved? And that took me quite a few years to actually figure it out.
How long have you said you've been working on the whole thing?
Really hard. I've been working on it since late 2017.
Okay, so that's still a long time.
Yeah.
7, almost 8 years.
Yeah.
Yeah.
So, and yeah, it wasn't until about a year or two ago where I really figured out what makes this thing tick and why. And it goes against all electrical theory in most aspects. And it's not actually really breaking any laws. It's just a novel way of going around the laws. So my motor doesn't experience lens effect because of the break and release spark gap switch. The second you release that spark gap, your current from your source goes to zero. Well, if there's no current going through the coil and the magnetic field has already collapsed, the lens law doesn't take effect anymore because there's no cogging. The cogging disappears. So I could hook up a load to it, and the motor keeps going the same speed with the same amount of current going into it. It doesn't change. A conventional motor, if you put a load on it, the motor slows down. That's because the lens effect of Ohm's law, all that stuff takes place. This motor doesn't know what that means because I've found a novel way of getting around those laws. Not
Okay,
that they don't
you
exist.
never have like the spikes. You just it's a constant, current.
Well, because you're like say on your motor you have say four magnets, for an example. So for every revolution, the spark gap is opening and closing 4 times. So if your motor's spinning at 750 RPM, well, times that by 4.
Hmm.
That's how many times that switch is opening and closing every minute.
Like 24,000 or something like that. Like,
Exactly.
oh,
Right.
yeah.
So the motor recognizes it as a current flow, but in actual fact, it's divided up 42,000 times. And that collapsing of the field happens, the current goes to zero or very close to it. That's where the efficiency happens. It's not that hard to figure out. And even Gerard Morin, when he was working on the similar devices, he said exactly the same thing. The second you have the spark gap on your source triggering, your current goes to zero. It drops instantaneously. Within a nanosecond, it's gone. But because you're doing it at such a high rate of speed, you don't see it. It's like, when you're a kid and you're making like your own little animations and you draw a picture and every single picture has a slightly different movement.
Yes.
Kind of like that, similar to that. It's a transition, but it looks fluid because it's triggering so fast. It's the frame rate, right?
Yes.
It looks like a fluid motion. No different. And the other forces that happens, you have the reactance happening in the coil, the collapsing of the field, and then you're got that hooked up in parallel, so it's like a dead short with the transducer. Well, we all know what happens when you either apply physical pressure to it, or you hit it, or you hit it with an electrical current. You get 40 to 50 times more power out than in. So that makes a transducer an over unity device. And they're everywhere. They're in the microphones that we use. It's a transducer. That's exactly how the microphone works. Actually, look up, if you guys have a chance, look online on how Thomas Edison invented the microphone. And you'll be very interested. It's actually really cool how he did it. Very interesting. They used carbon in a little chamber, and when you spoke, the little carbon beads would bounce around, and it would pick that up and create a current in the coil. It'd be surrounded, right?
Yes.
So, and that's how the microphone worked.
I think I have a book that has in detail a lot of the electronics. It breaks it, into smaller pieces, and I'll have to look that up. just to.
Yeah, transducers are used in sensors and proximity sensors. It's really, there's a lot of uses for a transducer, ultrasonic cleaners, stuff like that. And I use that in the Renegade, and I never forget that night that I hooked up the transducer to the Renegade, and the voltage went up 50%. I'm like, wow. I'm like, how did that happen? Because basically, I created a dead short with the coil with the transducer. The motor kept working and worked just great, and I got more power out of it. So I was like, wow, that's awesome.
Awesome.
You awake there, Philip? You look like you're pretty tired.
Yeah, I've got my. J'ai ma semaine dans le corps, disons. I got my week in the brain or something. I'm pretty tired. I didn't sleep. I went because I had to finish something for my employer
Right.
before I leave to Texas because he's doing a presentation next week, and so when I'm working on it had to work, and there was a huge bug we had to fix.
Yeah,
And
I know the feeling. It's like the month end, and we had to get all the stuff out the door. And the last 2 days have just been, they're like slave driving me to get all the stuff cut up. It's like, why are you guys leaving it to the last minute? Like, can you guys make the work spread out throughout the whole month and not throw it in the last 7 days of the month? So I lifted so much steel in the last week that would just like break most people. Maneuvering parts or steel into the machine with a crane. Yeah, I'm using a crane, but if the parts weigh or the steel weighs like 1.5 tons or 2 tons, and you still have to manually maneuver that piece into the machine and pull it out, and it's a lot of physical labor involved. Going in the forklift and loading it into the water jet. It's a really physical job, and I'm in my 50s now. I'm not 25 years old anymore, right? So
yeah, exactly.
I got my aches and pains, my shoulders, feel like my arms are gonna fall off my body. So it's a really physical job I do. Yeah, it's cool. I'm working with CNC water jet.
I used to spend all nighters frequently just trying to fix things so that they work the day after, but I can't do that anymore, man. At 2 o'clock right now, and during the night, I'm trying to work, and I'm falling asleep on my computer, man.
You know what? I'm the same way. It's like, like during the week, 10 o'clock, I'm in bed. No, I willingly go to bed. I need my 7.5 hours sleep. And it's really paid off, actually. It's really helped. So sleep is very important for your health.
Yeah. So for example, I went to bed at 2 a.m. yesterday, and I woke up at 5 or 6 to speed things up. So I fixed the bug, and I haven't slept, and I slept at 5 o'clock, but you could see me. I'm like knocking nails right now. I'm falling asleep very easily.
Yeah. If you need to go, we understand. That's totally cool. Yeah, we got another 25 minutes and we'll close it up for the night. But I know you need sleep, brother.
Yeah. So so is Mike Does still there, or?
He was there. I don't know if he's still on. I know Gerald's still hanging around. Yeah, the chat's been good tonight. We've had a lot of interaction. Yeah, it's kind of
Yeah.
well, it's Black Friday too, so a lot of people are. Oh, Ben's back. You have
Shopping.
to
Shop.
step
Oh
out.
my
Yeah, everybody's shopping, right?
like I took my kid to the mall. Like it took me just almost 30, 40 minutes just to like from the mall ring to the front of the store. Just like it was that packed. That's crazy.
So were there anything left in the store, or
I don't
everything was?
I just dropped her like front with her parents, and then like I wasn't gonna go into that madhouse. There's like I don't need it, right. I don't need it. Whatever it is, I don't need it.
Yeah,
Yeah.
that's funny.
No, but I hear you guys. Like, physical. Like, it's not just your jobs aren't just full, you know, or but also like intellectual. So it's not like you're only having to work.
Yeah,
You're actually having to work your mind with it.
yeah, and then you got your home life too. You know, you got a family, and you got to do shopping and make sure your son or daughter are well, and wife and everything. So yeah, it's like you have to put everything all together and want to make it work, right?
What's worse is what's bad is once somebody gets the cold, now
Yeah,
the whole family has the cold the day
yeah. Well,
after.
yeah. Well, my wife's sick right now. My daughter's not feeling good. They're both in bed right now. So yeah,
Yeah,
I'm
it's
that
been
club
going around.
the past couple of days too. Like the weather fluctuations not good for.
Yeah, come to Canada and tell me how bad it is.
Milwaukee, Wisconsin, man, like it got to like -40 there. There were like months that like 8 months, 9 months passed by. You don't get to see the sun. It's just
Oh yeah,
pure cold. Yeah,
Gerald knows all about that, and so does Philip. Philip, where he lives in Montreal, it gets freaking cold there, even on Ottawa too.
I
Montreal, Ottawa.
actually
oh
visited. It was November, maybe 2017, maybe 17. It's depressing. Stayed there for a week. It's like it's so cold. Like um, I think I wore like a mink coat and I was still freezing. Like really, really that cold. But yeah, I don't know how you guys do it up north. I really don't.
Yeah, like for me, it's like as soon as it gets below -10, it really sucks. Your whole body hurts, especially when you get older too. Your joints hurt and everything, and oh, it's such a drag. And getting into like an ice box for a car, and you have to heat up the car and get that going, and eventually you'll get
the,
some heat in your car.
the worst thing is when you forget to fill up your tank with and when there's not enough gasoline, it freezes, and you can't
Yeah,
start your engine.
yeah, that's why I always keep at least a half tank in the car or more. Than that, I don't have a problem.
Oh,
But
Yeah,
the old cars were notorious for that. Oh yeah, I remember back in the 80s and 90s. Yeah,
oh.
if
yeah.
you
I
didn't, if,
that wow, like that's
yeah,
cold.
yeah, like the coldest I remember here in Toronto would be about -42 Celsius.
40.
Yeah, you could spit, and by the time the spit hits the ground, it's ice. That's how cold it is.
Yeah, I've
No,
I've
it's true. Philip's laughing because he knows.
I,
Yeah.
Right?
I've poured water from our balcony like down, like and
Oh
it
yeah.
yeah, it just like
Oh,
dust.
what's really cool is when it's like -40 outside. Taking a bucket of water and go and throw it. It literally goes into a giant puffball of smoke.
Yeah, yeah,
Yeah,
feels like smoke. Yeah, yeah, very cool.
yeah,
I mean, there are fun things in the north with the cold, but not everything. But yeah,
yeah. It's good for the kids. They like it. They play in the snow, all that kind of stuff. But when you get older and you got to drive in it and get up early in the morning, and it's like so cold, it's just makes your life miserable.
Well, I
But-
think the worst is when you go live in the south, like I did in San Diego, and then every night over there is like it's sunny until 11 during the night. It's sunny until 11. The sun sleeps at 11 because
Yeah.
you're near the equator.
Right.
So and everybody is very
Where's
lively.
it,
And
San
then
Diego?
sorry,
San Diego it goes that late?
yeah, San Diego.
Really?
And
I
it's,
didn't know that.
yeah,
'cause I
it's very
know-
sunny.
Yeah, because here I think the latest it's sunny is till about 9:30. That's when it gets dark.
Well, right now it's around 5 or 6. It's
Right,
already
Right.
already gets dark, but over
Yeah.
there it's 10 or 11 all year long,
Yeah.
and then you live there for a couple of years, and then you come back, and then that's very hard. That's very hard to come back here, actually.
Yeah. See, like in the Philippines where my wife's from, the sun sets every day at 6 p.m. But sunrise is at 5 o'clock, 5:30 in the morning. So
Yeah.
it all depends where you are in your latitude, right?
Yeah, exactly.
Yeah.
So, hey, the X Factor.
Yeah. The benefactor.
Yeah, so I did have something to show you guys. I don't know if
Yeah,
everybody
I
saw
was
it.
going to ask you. Yeah, I was going to ask you about that.
So I've been working on something with Michael Morell. He designed a circuit, and we are going to be selling the Lightning Thief soon. And this is the prototype. I'm going to be sending them out as many as I can afford to you guys to test out. It's not producing over Unity, but it's not to say it's not possible. We have to tinker with it a little bit. What it is doing really well is it's able to squeeze batteries really well and multiply the voltage at a significant rate while seemingly maintaining the current. The problem is with the circuit is it's significantly reducing the power factor at the moment, with the duty cycle being at like 5 to 95. And I believe that's because it's not a true AC sine wave. But we are working on tinkering with that, and we want to get it out to you guys specifically to test with and see if you can tinker with it. So that's pretty cool. And I also have another video to show you.
Sure.
Because I don't think
there.
I don't think all of you. I think a couple of you saw it, but not everybody. And it was a really cool video. I'm really, really excited to show this. All right, everybody. Here's something really cool. We have the stereo method hooked up right now. Okay. 10 volts from our power supply at 140 milliamps. Okay. We're going to spin this little neodymium magnet, and we're going to monitor the wattage. Okay. Oh, it's not going to show it. Oh, you got to show it. There we go. Okay. So, 7.3 because we don't have it on. We're going to turn it up. Check this out. Okay, let me take that. I'm going to take the magnet out first. Okay, we're going to turn it on. I'm turning it up. Look at the watt consumption. 24 watts. Okay. Now watch this. We're going to put the neodymium magnet in there, spin it up, increase the frequency. Now check this out. Wow. And it goes back up. 24.
There you go.
We saved 10 watts of power by spinning this thing.
Exactly.
Holy crap. So I thought that was really, really cool.
Yep.
And not only that, I do have, so we have 2 products lined up for 2025 because we had a lot of people reach out to me who wanted to actually buy some of the stuff that we're working on. And I want to provide it for you guys at a very cheap cost, those of you who reached out to me, just because I want to get this technology into more hands. And what we're doing is I'm working with Michael on a true AC sine wave circuit, but for now he has built an AC square wave circuit, a pulse wave circuit that will be included in this thing. This will be green. It's going to be called the green machine. And what it's going to have is it has right now in it an Arduino, and then it has the Drox mini amp board, right? And this is specifically what I was using for this test right here to pulse the magnetic rotary and get the neodymium sphere to synchronize and drop that wattage. So we're gonna try to get these out here. Maybe not with the stereo amp board, maybe with Michael's circuit. This is going to be farther down the line. This is just a concept at the moment. And this LCD screen is going to be used with some kind of circuit, maybe a mini Arduino or Arduino Uno or something. And it's going to be able to hopefully monitor the input wattage and output from the circuit as well. So you actually can use this as like a Wattman, and monitor that while you're pulsing your rotary. So we want to get those devices into more hands, and I am working on a rotary for the APA coil, but further testing is going to be needed to decide what the most efficient design is going to be to pair with this thing. But we're really excited because Michael has been working hard on making a couple of circuits that we can actually put out there for you guys that works with these coils that I've been using. So
awesome. Right on. Yeah, that'd be interesting to try that circuit out. Have a few ideas with that.
But that's amazing. And like the different 10 watts, was it right?
Yeah, 10 watts drops. So, and again, we don't really have any practical application for that at the moment. That's why I'm hoping to get this technology into more hands so we can develop it further. But there is one practical use for it, and that's wireless induction. And what it does is it's able to wirelessly induce electricity very, very efficiently while lowering the input wattage required to do that. So while the magnetic rotary is spinning faster and faster at the RPMs, which is another feature that we want to include in the green machine, the LCD screen, want to be able to monitor the input and output wattage and also the RPM, which we can do, of the rotary. So you can kind of tune it. And the faster you can get it to go, the more that wattage is going to drop.
Very cool.
Mm-hmm. Yeah, it's really exciting.
It feels that
probably. I think what's happening with your setup there is the spinning magnetic field is actually increasing the frequency. When it's increasing, when it increases the frequency, the wattage goes down. That's where the efficiency is. So you're using the magnetic ball or the neodymium magnet as kind of like a dynamo. It's spinning. And when it's spinning, it's creating the oscillating field in your rodent coil. It's changing the frequency of it. And when it changes the frequency of it, if you hit that sweet spot, or when the coil or the rodent coil goes into resonance because of that spinning field, that's when your wattage drops.
So I have a theory as well, and the theory is if we can get that neodymium sphere to synchronize at the coil's natural resonant frequency, which it resonates in an open circuit around 6 kilohertz or whatever. So if we can get it to spin up, and with the tuning method that Michael and I have discovered, we might be able to slowly increase it to the natural resonant frequency, and maybe like the Nunez method, open circuit, kind of multiply that output a little bit, not
Right.
just
So
reduce the input.
yeah, so what's working against you right now with the neodymium magnet is friction and mechanical losses,
Yeah.
right?
Yeah, the only thing
So
that's overcoming that a little bit, I think, is just the fact that I'm using glass, not because
yeah,
it's slick, but because glass just has a natural ability to amplify, it seems, the magnetic field interaction. And we've actually proven this on live stream, where we'll put a little small thumb magnet in the center of the vortex, right, at a very low input, and it's like in plastic container, it's not moving at all, right? And then we don't touch the power at all. We switch it, put it inside a glass container the same size, and it starts flipping around real fast. Like something with glass interacts with the aether.
Well, it depends on the relative permeability of the material.
Mm.
So,
yeah.
yeah.
Well, glass is a dielectric, so that could be something reason why. See, the faster that magnet spins, so you're saying resonant frequency is 6 kilohertz. Okay, that magnet would be spinning so fast it would be
Oh yeah.
scary.
Oh
It'd be
yeah.
scary.
So, and there might be a factor at play here because I'm using a closed circuit there, so that might not be the resonant frequency. That's the resonant frequency I get with the open circuit. It might actually be lower than that with the closed circuit.
Okay.
So, but yeah, you're absolutely right. The faster you get that, it might be scary. And but I have a feeling that that's how you synchronize the neodymium sphere, like how we see in the videos, like Jack Scholes and Daniel Nunez synchronize that sphere to the point where they can actually take it outside the vortex and it'll keep on spinning, and then power down the coil and it'll keep on spinning. Like it won't slow down. It'll speed up a little bit before it starts slowing down. It's really weird. But you can tell it's completely synchronized way outside of that vortex, like 25 feet. I think that might be how you do it. And he said it's spinning so fast, it's dangerous. Like you got to wear gloves. It chips the glass. So you might be, you might be right on that. So we're getting close though. We're getting really close. I got it all the way up to 1 kilohertz, I believe. Yeah. Or close to 1 kilohertz.
Levitate out of the glass.
So what it will do, I think, at a certain point, is it will, if it's not too heavy of a neodymium sphere compared to the donut shape or size, I think it will, like, that's how they get it to levitate in the center, because you see videos of people getting the sphere to synchronize in the center and just levitate there. I've not been able to do that yet either, but apparently it's easier than synchronizing it fully where it is able to be affected outside of the vortex. So that aspect is interesting, because you can see, when you power off a system, you get that spike, right? That energy spike. You notice like a motor or like a fan or something. It gets that kick a little bit. You turn off the system just for a slight second. So I don't know.
No, you're right. Yeah, you're on it. It's just a matter of designing an enclosure that would handle something spinning at that amount of RPM. Because as soon as you get over, say, 10,000 RPM, it starts getting pretty gnarly.
Right.
You got to be careful, because if you get a runaway, that thing will shoot out like a rocket.
Well, what I was gonna
be on
the thought that I wanted to finish that I didn't actually finish was when that spike happens when you turn it off. When you see the video from Daniel Nunez, he's got it like held like 10 feet outside of the vortex, right?
Yeah,
and when he turns it off, though, you see it spin up a little bit faster, and that's it's completely synchronized. That's how you know. There's something weird going on there, and we're right on the verge of trying to replicate that. That would be so cool to do, but it's dangerous, very dangerous. Like you said,
you're getting up to gnarly speeds there.
And we have a tachyometer now, and when I last measured it, at around that, I think it was that test, it was around like what was it, 78,000 RPM, and that's only half of what I've seen it.
Yeah, see, like there's a guy, I forget his name. He's working with Aaron Murakami. He's rebuilt the Tesla turbine,
Mm-hmm.
and his Tesla turbine is spinning at 58,000 RPM.
Wow. Yeah, it gets really it's fast. And again, my
That's
to emphasize, my tachyometer isn't probably the most accurate. So, it could be off, but it did register at around like 78,000 RPM for that sphere. I'm like, what the
Dude, the speed you can start thinking about anti-gravity.
mm,
Yeah.
yeah.
If you can have ball bearings rotating at 78,000 RPM, then it's going to create a pull.
Yeah. Like even Tesla said when he made the Tesla turbine, he says this machine is too powerful. It's scary.
yeah.
And I believe it. Because I know that guy working with Aaron Murakami. I forget his name. I don't know why I forget his name. But his is spinning at like 58,000 RPM. That's insane. That you get a runaway on that?
Mm-hmm.
Oh, you got problems.
Hey, Mike, I have something to share if you guys don't mind.
Sure.
Yeah. Welcome back, Nathan.
Oh, thank you.
That was fast.
Yeah, I tried.
Yeah.
All right, so you were talking about the transducer and how it amplifies.
Yeah.
So I'll show you right here. This is the oscilloscope reading from amplifying the transducer and what it does to the actual cold energy. And you see that jump, right? Every time?
Yep.
So I'm pushing the button in order to get that to jump, and it turns it off. Turns off the transducer, just like you said, shorten it out.
Right.
So I'll show you real quick when it gets to the let me just pause it. You'll see 160 millivolts right there on the right hand side. And once you amplify it, it goes up to 320.
See, there you go.
So it actually doubles on both sides. It'll go 320 on the positive side. Let's see if I have it right here. Right there, it's 320 on the negative side.
Yeah. See, there's the over unity device right there. It's right. We're using it, for microphones and ultrasonic cleaners. It's a over unity device. It's in industry. It's being used. And there's your proof right there on the oscilloscope. Twice the power coming out, what you're putting in. And they say it's impossible to do that. Well, there it is right there.
Yeah.
How can you deny that? How can they say over unity is impossible? It's ridiculous.
Yeah, it gives you all the proof you need right there. Like I said, just pull up the first reading, 160. So double it out.
Exactly. I'm just going to scoop for another smoke. Philip, I know you're really tired, man. If you got to go, I understand. You're beat.
Yeah, I'm beaten, man. So I'm gonna go. So thanks a lot, bros, and I'll keep you updated on the next Friday. I'll let you know what the hell happened to me. And
Well, good luck, Phil. I really hope you do well.
Yeah,
yeah,
good luck.
thanks.
Yeah,
Thanks.
good luck. Good luck. Get some rest.
Yeah.
Awesome. All right.
Okay.
We're rooting
Take
for
it
you,
easy.
buddy.
Okay, so I'm going to scoop for a smoke. You guys just chat it up. I'll be right back.
Yeah. Oh, man. So what did I miss? You got to talk about some cool stuff or what?
You missed Ben's experiment.
I saw Ben's experiment this last week. It's the same one?
Yeah, the Wattman experiment. Oh, so cool.
Nice.
Mm.
I miss Ben getting all excited over it.
No, it's cool. We're gonna do some more experimenting with that soon. I haven't got the V-Gate motor to work yet, though, unfortunately. Oh, just lost my headphone. So what it is a power factor. I think the stand that I have for it is just too high above the donut. Yeah, and if I increased the power more, if I had more power to it, I probably couldn't expand that and hit the V-Gate. But right now, I don't have the ability to do that, so I'll just redesign the stand. Maybe get a little closer.
Well, that's cool, man. At least you're trying for it. I mean, that's kind of a get your math right and go for it once type of deal.
Yeah, and Michael also, he actually has a working pulse motor circuit that he designed that he's actually going to send me a couple of prototypes of. So that's going to, and he got it to work fine for him. He also designed a little rotary that we seen Daniel Nunez use, just like a PVC pipe that sits around the donut tour, and it's just a shaft with a cylindrical magnetically magnetized, is that right? Magnet. So it means it's like split into like quarters or halves or something like that.
Oh, okay.
Yeah, so it's not diametrically. I think that's the right word.
Diametrically, that sounds right.
Yeah, so that's how it's magnetized, and we're gonna use that. Probably be a better thing to use, in my opinion, than the V-Gate. We might have to use V-Gate for something else. It's pretty big, unless we had a huge, unless we get like a huge, coil. Just put it right in the middle.
You ought to make one of those little pancake coils. They make good pickup coils, Ben.
Yeah. You've been telling me to make one. I should probably just go ahead and do that. Make a pancake coil, and because I do need a pickup coil. That's something that I need to make.
Well, they're just speaker wires, so it works out really easily in order to build it.
Yeah. You don't have to really do much. Just kind of twist it up or twirl it up, whatever.
Just get your super glue ready because it likes to unwind itself quickly. So you have to glue each wind.
That makes sense.
Yeah, but as long as you don't stick your fingers together halfway through, you'll be all right.
Well, I've glued my fingers before.
Yeah, I did it too. I had to unglue them while I was building this thing. So, I mean, it is what it is, but mine was kind of excessively big, but the good thing it was, because at 12 inches, now it's perfect size for that rodent coil. And man, it picks up energy quick off of that thing too.
You said it's 12 inches?
Yeah.
I'll have to keep that in mind. And your coil is the same size as my Fireball coil, so I'll use that as reference.
Yeah, the cool thing was you can set it right on it. And because it's insulated on the wires because the speaker wire, man, it works perfect. So you don't have to worry about any spark over or anything else. It just instantly goes right into the wire. So it's a beautiful thing to use.
Unfortunately, my Fireball coil is not working at the moment. I tipped it over, and the ends that aren't soldered, they're taped into a bundle. I don't know. The channel B got messed up, so I have to figure out. It's not maintaining continuity with one of the wires now. I screwed with it for like 2 hours the other night. I couldn't get it. Well, we might have to just scrap the wire and redo it because it's on the fritz. Yeah.
Yeah, you didn't tear off all that tape and just, buzz it out and see if you got a miss?
Yeah, that's what I did. I took out all the tape and I tested it wire by wire. Everything is fine on that channel except for one wire. And it's just like it maintained the continuity once when I twisted it a certain way. And then after that, there's some kind of short or something. I don't know. Honestly, I'm not really sure what's going on with it. I'll figure it out eventually. But if I can't, we'll just have to replace the wire. It's no biggie. I need to twist some more up, which brings me to mind like my idea for, kind of like twisting up for people who can't put together a coil like that. We can twist up the wire for you and solder it, the channel A and channel B, and then all you have to do is pop it on the coil frame, spool it up, pop it on.
Yeah, I guess. It seemed like a little different process when I did it. I always had a big old length, like extra wire left over, you know what I mean? When I did it.
Yeah, you'd have to measure it perfectly, but I think it would just be like an easy way to streamline the process for somebody, who is not keen on, soldering and all that stuff. They just want to get the coil frame and wind it up. Like if we ship it to, I don't know, like Victor, he wouldn't have to do any soldering or anything, just put it on the frame.
Yeah, I get it. At that point, you might as well put it on the frame for him and call it a day.
Yeah. No, that's true. That's true.
It really wasn't that much more work. You should have seen it, Lulu. They had like a 2-foot long needle is what it felt like. And you're putting this thing through the center of the rodent coil and you're sewing it is basically what you're doing. And you're just sliding it inside each notch as you sew it around there. It literally felt like that. It took about 20 minutes to do, but
so Michael had he had somebody ship him a really nice custom made coil, and this happened, I guess, he said for the second time. It went through customs and they drilled a hole through it. Like it was a really nice, expensive one too.
Man, that sucks.
Yeah, I was like, dang. So, at some point, I might just start hand delivering some of this stuff if I can.
Wow. Well, that printer I sent you got there, so in the U.S. it might be fine.
Yeah, within the national, it should be okay. And we can start to cross borders, maybe. Yeah, because I think that was he was shipping it from Mexico, I believe. I could be wrong on that. I could be wrong on that.
Yeah, that would cause an issue.
Yeah, what gauge are you going to go on your Fireball next, Ben? You going to go up to 20?
Yeah, I think I'm going to go higher just because I want to be able to carry that current a little more and close the gap a little bit more in the center of the Tor. You don't want too thin of a wire or too much of a gap there because I'm noticing the closer those wires are on the inner diameter, if you can get real close without touching, that seems to help with the amplification, the multiplication that you see with the voltage or whatever.
Gotcha.
Resonance. Yeah, it's just a theory, but
closer, the more resonance. The closer the wires are together, crossing.
Yeah, it does seem like if they're farther apart, you get less voltage amplification. Like with the other coils, with the Mark, for instance, for the Mark 1 coil, with the Nunez open circuit method, we get approximately 21%, 21 times voltage multiplication. So say we start out with 10 volts, we times that by 2021, and that's, how much we get with the Nunez method for our amplification. But with the, say the Christmas coil, which is a lot wider, and a lot more open, not as close together. That one only gets around 10 times. So I'm kind of I could be jumping the gun on it, but it's just a feeling that I get that, the closer those wires are without touching, the more we're going to increase the field strength of those two counter-rotating fields, if that makes any sense.
Well, think of it this way, like you're putting magnets into a center, right?
Mm-hmm.
And the more magnets you put in there in one direction, the higher the Tesla value. So if he can get more fields, but in a smaller area, then that's what he's trying to do.
Yeah.
So coming out of the center of the coil, when it flows into it, it'll just put him a higher Tesla level in the middle. And that's where more of the energy will pool into.
Right. It'll create more of that pinch point like you describe in your coil. Yeah.
That's exactly right.
Awesome.
Because you can put a Tesla meter on it, and on the outside it'll be very low, and on the inside it'll be very high.
Right. No, that's a good point. Awesome.
Yeah, every time I look up Tesla on Google, it keeps showing me the cars. It never
wah, wah, wah.
Drives me nuts. Yeah.
Well, it does
didn't want
to
to see
me
that car. I
too.
want to see the real guy.
Yeah.
Know what I find too? Tesla people who drive Teslas drive the same way people that have Beamers.
Yeah. Well, they do. That's for sure.
Yeah. It's funny you said that because I think the same thing.
What's even worse, they got more power at their fingertips. You know what I mean? With that Tesla.
I know. That's even worse.
Oh, that was bad during the holidays.
At one point, your Renegade, you could sell it to Tesla, like the people that have Tesla cars, to charge their own cars. They could put it like in their trunk, and they could just hook it up, and then you know anywhere. And so yeah, I mean, right? Don't they, like, if they run out of power, they need to stop somewhere to charge that thing? Well, they could have it like on demand charge in their car, where they don't have to stop anywhere to charge it.
Oh yeah. Well, you put something like this, like we're building in a car, and you're just not going to stop till you get to the other end of the state. Maybe, maybe through Canada and back. I
Yeah.
mean, it's a lot, man. It's getting crazy on how we're getting there.
I think that would be the optimum, for a car. Like, you'd never have to fill it up ever, or stop, or plug it in, or anything. It's always full.
Yeah. Oh, I saw the coolest thing today on the Facebook news groups. Guy's got an older motorcycle, and he put a hydrogen generator electrolyzer in the motorcycle, and it works great.
Hmm.
It's running it on water.
Yeah, I keep seeing that they keep doing those water ones, man. I want to get into that, but I'm so stuck in what I'm doing right now. I don't have time yet.
I know. It's just, I got to focus on the one thing, right?
Yeah. So
Did you have Thanksgiving, Nathan? Because you're in the state celebrate Thanksgiving.
We did what?
Did you have a good Thanksgiving?
Yes, I did. I had my granddaughter the whole time, so I was chasing after her everywhere, and she sat and ate with me and everything. So she just got to, she just started walking. So yeah, she's like, oh, I'm everywhere like this. You know what I mean? Just she's all into it, man. Just running around. You can't slow down either. Just it's one speed, man. It's all or nothing.
That's funny. That's cute.
So
well, yeah, it's great having young ones around. I remember those days when my daughter was that young, just starting to learn how to walk.
Oh yeah,
you get all paranoid if they're gonna fall and hit the coffee table, or stuff like that. Oh my god! I swear I got
strap a helmet to their head.
Yeah.
Yeah.
I had that phone everywhere. Like the phone taped it everywhere, to every little corner.
I probably would have did the same thing if I had kids. I probably would have did.
Yeah, you lose part of your life during that time, because like every 2 seconds you're like,
Yeah. Oh, I know. That's where the gray hair starts.
Well, I tell you, I'm thankful we didn't have kids in our later life. The wife and I, you know what I mean? Because these grandkids, man, I can't keep up.
Yeah.
Like, it's different when you're in your 20s and 30s and you have kids, man. When you're getting close to 50, it's a haul to run after these little ones.
God bless them, keep them, and kids are, kids and grandkids are good. I don't have any grandkids, thank God, but kids are wonderful. I've got like 4 of mine.
Yeah. Well, I started a little bit late. I had my daughter when she was born. I was 39, so it was getting out there. Now I'm 51. I've got a teenager.
I started at 23. I have a 20-year-old, and I have a 14-year-old, a 13, 12. Yeah.
Wow. I started at 19.
Wow,
Wow, that's young.
that's young.
Yeah. I had all my kids young, man. So,
I mean, you grow up with them in a way. If you think about it, like,
yeah. They didn't get quite the wisdom they would get now, but you know what I mean? They got the youth of running around with them and doing stuff. So all the theme parks and stuff like that. And you know what I mean? They all get to go into the fun stuff. Because I couldn't handle that right now. There's no way. I'm not going to one of those places.
Yeah. In the same way, roller coasters, no, can't do it no more.
Yeah.
I can. I love roller coaster. I'm like, no.
Oh, I love them. I love them. It's just my body can't handle it.
Yeah. I don't know that I can handle the line. I get really impatient now. Yeah.
Oh, I got off one of the rides at Canada's Wonderland. It was a year ago or whatever. I got off and my head was just scrambled. I'm like, oh my God, like, what the heck?
Yeah. Yeah, I don't need to get dizzy and throw up on one of those big old roller coasters anymore. If I want to throw up, I'll just turn my testicle all the way up, man, and I'll be out barfing.
So Phil sent an email a couple of days ago. He said like it's almost this group's 1 year anniversary.
What was his 1 year anniversary?
Fair, like this group's like the League of
Oh,
Extraordinary.
it's been a year.
Been a year.
A year already?
That's what he said.
Really?
Yeah, like it's been a year. I know.
That
I
fast
just
already?
think
That's
like
mind-boggling. I didn't
have
even know.
to podcasts already. Like think about it. Like in a year. Yeah.
Yeah.
My YouTube channel is pretty huge now. Like I'm pushing like almost 500 videos, and
Wow.
God knows how many live shows I've done. I have a huge selection now. Community section, huge. Like
Nice.
I have a lot of content.
Very good.
I'm barely around 300. I got a while to go to catch up to you.
Yeah, I've been at it since. Well, I've had it up since 2010, I think, but I didn't really start getting serious with it until about 2017. So, yeah. So about 8 years. Yeah.
Well, both your guys' channels are doing really well.
Yeah, I'm at 32, almost 3,300 subscribers, monetized. Yeah, got tons of content. So, like, I get people, making comments if I did videos on like 3 years ago.
That's
And I
good.
still, yeah.
That is really good. That means you have a lot of replay value in all your videos,
Well,
That's good.
yeah, and that's part of the reason why I was able to get monetized because of that, right?
Yeah, I think it's a common theme actually between you, me, and Nathan, and a couple other the YouTubers. All of our videos are really like people love to like consume them and watch them in full because they're just so full of great information that you can't get anywhere else. It's like finding a golden nugget in YouTube, and like people they have a tendency to rewatch it or apply it in different ways and watch it in full, come back, whatever.
Yeah.
Yeah. If you keep your content doing the same stuff all the time, you're good. Like I know one guy out there, he started doing over Unity stuff, and then he got involved with a few people and did some special project, and then his whole channel just did a complete 360. He doesn't even do over Unity devices anymore. Like the last one I've seen him do was like some remote control airplane or something like that.
Yeah, so that's something that we have to commend ourselves for. We don't follow the trends just to get we stick to our content. We stick true to our content. And that's what's really appealing, I think, to some people is that we're not just recycling like all over YouTube. I see the same thing recycled in a different channel, trying to get a boost from the same hot topic or whatever. And I'm just like, at a certain point, you got to have something original out there, or I'm just I don't know. Like I have a feeling like that kind of content is slowly dying. and people aren't just, they're going to be looking for unique stuff because all you see is recycled content.
Yeah.
And
Yeah.
it's it gives them like the viewer an opportunity to ask questions live, not just on a pre-recorded video that's
Right.
playing. So there is that time where people could actually engage in the topic, back and forth. It's not just you dump information on them and that's it.
That's a good point. And when you can have your channel succeed with primarily live streams, which is what I'm doing right now, basically that's a really good sign, because live streams aren't really the key driving factor behind YouTube's algorithm. That's really, and live streams are rare. You have to have a really good channel with dedicated, loyal followers to really succeed in the live streams, and that's what we're doing. So I think just building on that, we have a whole movement of new industrial revolutionists who are ready to utilize the 0-point energy technology and open source it, to as much as possible to get it into as many hands as possible. Because we are, on the verge of, having a real economic crisis. A lot of people, not just in America, but in third world countries all over the world, people are struggling to get that energy for cheap. And if we can provide a cheap solution that we can get out there, I think that would be, something that I would like to do, at least.
Well, I still kind of consider what we're doing kind of niche on YouTube.
Oh, yeah,
And,
it is. It's almost like a niche within a niche.
Yeah, because, it's not like these kids channels where some of them are getting 2 and 4 million views a day.
Mm-hmm.
Like, how do you compete with that?
You really can't unless you build a loyal fan base, loyal viewer base, people who are dedicated.
And that takes time.
Mm-hmm.
I've been at it, almost 8 years, right? So now I've got a bit of following, I got a lot of viewed airtime hours. That's why I was able to monetize. So it was just, I had to go at the snail pace, right, to get where I wanted to go. But I'm there. And,
What's good? It's something like this, in my opinion, is building a more stable foundation. Whereas if you get trending off of like a hot topic, say you go viral, that's kind of like hitting the lottery. And at that point, if you're always going to be struggling to recreate that, but like you see that people stuck in the topic that got them, popular, like, I hate to say it, but Ashton Forbes, he's in the same boat. He went viral off of what he's doing, and I think he peaked.
Right.
I don't know, man. I saw a thing today. He had like 400 people sitting there on his live chat. I think he's doing fine.
Yeah, but I'm saying he hasn't really had as much growth since then. You know what I mean? Like his growth has kind of stagnated compared to when he went viral originally. So it's just like it's a different route, but it doesn't leave us confined to speak about one thing or the other. We're building a better foundation in that respect. And I think, it's nice to go viral, but I think it really is counterproductive in a certain respect.
I don't. I've tried like almost strapping myself to the chair to continue like a full episode. Like the way he talks gets on my nerves.
He's more mainstream though. He's more mainstream.
Like just like, I cannot finish his tone, his pitch, the way he really irritating to watch fully. It's like I have to take a break and then come back and then but it's just to continuously watch.
Well, I'll be honest with you guys. I'm a little to the contrary of you guys. I watched his channel today and I was quite enjoying the content. And then, and then he did Mark Sokol on his channel as well. I enjoyed that interview. So there's a couple of different ones that I saw him in and were pretty good. So I did, all that tone doesn't bother me.
I'll say, let's say not today's. I haven't watched today's, but let's say the last 4 before today's. One he started cursing at somebody, and it's like, dude, like you run a.
Oh, was he really? I didn't see any of that.
You run a scientific channel, like that's not cool. You know, just don't talk about it if you don't like it. You know, a certain person. You know, that's that. But anyway, I think our channel is cooler. Your channel, you
Yeah.
know, yeah. You know, we
Well,
talk.
I'm like 60 away from 6,000 right now on my subscribers.
Oh, there
And
you go.
then what was it? I think I'm close to almost 60,000 views
Yep.
in
That's
just
good.
28 days.
That's good.
Very
Yeah, within like a couple hundred of it right now. So,
Yeah, the highest I think I got was 74,000.
oh, I hit a day where oh God, the whole month, I want to say I picked up several thousand subscribers within 30 days.
Really?
And
Wow.
yeah, and I was hitting, probably like 150,000, what I mean, views on there. But
Yeah, I think the Graviflyer, because of that, the Russian guy who came up with it, I think he went viral, and
yeah, he did.
because of that, the Graviflyer, when it comes up in the algorithm, your channel comes up, so you're able to feed off that, which is good. Works to your advantage, right?
Yeah. Well, anytime that you can get in there and almost take over a topic when it comes up, you did something right. You get that algorithm to work for you.
Yep, exactly. Like I noticed, like one of my old videos, I did the N machine, Bruce Obama's machine.
Mm.
That video still has the most views I've ever done for video.
Yeah, it's all about how you name it, huh?
Yep,
Kind of crazy.
exactly. Well, guys, I think we're going to end it today. I'm pretty beat. It's been a long week. I'm sore.
Thank you for your
It was the
show.
1 month. Yeah, so don't forget, everybody, next Friday, League of Extraordinary Inventors will be hosted by none other than Nathan. He's going to take over again.
Right on.
Yeah, check out Old Man Builds. Don't forget to subscribe to his channel. And I'll try to pop into the chat that night and say hi to everybody. So everybody who's American, having your Thanksgiving, happy Thanksgiving, and best wishes to everybody. And yeah, we'll see everybody soon.
Right on. I just want to say goodbye. And Bernie, thank you for the good comments today. I appreciate it.
Excellent. All right, Ben, Nathan, Lulu, have a great night.
Have a good
night.
night,
Have a good
everybody.
night, guys.
Take care.
Bye.
All right, we're off.
Good night, Mike.
Yeah. Take care.
All right, everybody. Give me 1 second. Let me put myself back up here. I'm gonna go and do expert. All right, just to prove a point, not to be mean or anything, but you're dead wrong if you think that Ashton Forbes hasn't peaked. Look at his numbers. He's down 20.1% on his followers for the last 30 days. For the last 30 days, he is down 26.9% on his views, and following gained weekly, he is down 80%. So, yeah, to those who say that he is still growing exponentially, I don't think so. The proof is in the put in, not the pudding. That's common misconception about that saying. It's another telephone game. But the proof is in the put in, meaning what you put into it. And this is what he's put in to the data. And the data says that anybody who thinks that he is not peaked is wrong. So with that, I'm going to end the stream. I appreciate you guys for tuning in. I appreciate all the love and support. Happy Free Energy Fridays. We'll see you Monday for the Fringe Think Tank. And thanks for tuning in. Bye.